Very good morning to one and all. I take this opportunity to extend a warm welcome to all the keynote speakers, invited speakers, paper presenters, delegates from various corners of the globe. Now I request Chief Guest of today's function, Professor KPR Shastri Garu, please come onto the dais and occupy the chair. Now I request Bindu Madhavi, honor him with a bouquet. Now I request guest of honor today's function, Professor G.P. Rajshekar Garu, IIT Kharagpur, please come on the dais and occupy the chair. I request, yes, Joshna, please honor with the bouquet. Okay. Now I request another guest of honor, Professor P.P. Murthy Garu, please welcome. So, online, joining us online. Now I request Director of today's international conference, Professor Anuradha Kameswari Garu, please come on the dais and occupy the chair. Now I request Shravani to honor her with a bouquet. Last but not least, I am Professor C. Srinivasarao. Sorry. Now I request President of USNS of this today's conference, Professor K.K.M. Sharma Garu, please come on the dais and occupy the chair. Sorry, sir. Now I request Shravani Bhargavi, please honor him with a bouquet. I myself, Professor C. Srinivasarao, as an organizing secretary of today's international conference. Thank you to one and all. Now, I request President of the function by Director of this international conference, Professor Anuradha Kameswari Garu. Please.
Program starts with lightning of the lamp.
In the mic on.
I request the dignitaries on the dais to join for the lightning of the lamp.
Sir, needed. Anna. Babu. Sir.
Next we have prayer by Professor M.E.R. Kameshwari Madam. गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि गानचतुराय गानलोलाय गानान्तरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुकमनसे गुरुपूजिताय गुरुदैवताय गुरुकुलत्वायिने गुरुविक्रमाय गुह्यप्रवराय गुरवे गुणगुरवे गुरुदैच कलाक्षेत्रे गुरुधर्म सदाराध्याय गुरुपुत्र परित्रात्रे गुरुपाखण्ड खण्डकाय राय गीततत्त्वाय गीतगोत्राय धीमहि घण्टमत्ताय गोजप्रदाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि. Thank you. So I start the proceedings with the welcome event. Respected Chief Guest of today's function, Professor K.P.I. Shastri Garu, Chairman and President of UASMS and SMSMS. Our guest of honor, Professor G.P. Rajshekar Garu from IIT Kharagpur, and Vice President of UASMS, Professor K.K.M. Sharma Garu, President of UASMS and Vice President of SMSMS. So Professor K.K.M. Sharma Garu, and Organizing Secretary of this conference, Professor C.H. Srinivas Rao Garu. Invited speakers, participants, guests from various departments. Good morning, everyone. I am, first of all, sorry for the delay. And I'm thankful to our in absentia Chief Guest, Professor, our Honorable Vice Chancellor, Professor PVGD Prasad Reddy Garu, for permitting us to proceed with the conference. And I am very much delighted to welcome you all to this international conference on Pure, Applied and Engineering Mathematical Sciences 2024. This is being held in the Department of Mathematics, Andhra University, in collaboration with the two eminent societies, Uttarandhra Society for Mathematical Sciences and Meenakshi Sundaram Mathematical. Firstly, I thank our visionary Vice Chancellor Sir for his support and encouragement given to us. In spite of short notice of about 1 month, Sir has permitted us to move forward and organize this conference. Next, the respects are due to Professor KPR Shastri Garu, retired professor of this department, chairman of UASMS, for initiating Professor CSR Sir, short form of Professor C.S. Srinivasarao Garu, to organize this conference. Andhra University, under the able leadership of PVGD Prasad Reddy Garu, is accredited by NAC with A++ grade and secured a score of 3.74. That speaks volumes of this university. The Department of Mathematics was established in 1932 with Dr. Sarvepalli Radhakrishna as founder head of the department. And this was further led by many eminent mathematicians who contributed to various research areas in mathematics like analysis, algebra, number theory, complex analysis, functional analysis, etc. Presently, the thrust areas of the department are nonlinear functional analysis, fuzzy algebra, ordered algebras, differential equations, mathematical modeling, number theory, and cryptography. The department has so far produced 149 PhDs, 112 MPhils, and published more than 900 research papers, both national and international. The objective of this conference is to share and extend the knowledge with eminent academicians and researchers that contribute to innovative ideas for collaborative later research works. I feel proud to inform that the conference has close to 250 registrations, both online and offline, with keynote and invited speakers both from India and abroad. I take the opportunity to thank Andhra University, UASMS, SMSMS, and all the other institutions for their financial support extended. Now I welcome all the invited speakers and participants and wish a happy stay that enriches the knowledge in mathematical sciences in this conference. Now I request our organizing secretary, Professor C.H. Srinivasarao Garu, to say a few words about the conference.
చెయ్యాలి ఎప్పుడైనా లేపుకోవాలంటే ఇలా లేపు ఇలా తీసుకోవచ్చు ఓకే
Before reading this about the conference, first my namaskarams to legends of the mathematicians, Professor K.L.M. Sharma Garu, K.L. Swami Garu, Professor Avadani Garu, Professor J.C. Rao Garu, Professor Rajendra Prasad Garu, Professor M.S. Murthy Garu, Professor Rajshekar Garu, Professor Dhananjay Garu, Professor Krishnarayana Mishra Garu, and Professor Board of Study Chairman, my Lalvesha, Professor P.D.N. Srinivas Garu, and Professor Nanaji Garu, my Director of today's international function, Anuradha Kamishri Garu, President of USMS and Vice President of SMS, Professor K.K. Sharma Garu, my esteemed colleagues, Ramakrishna Garu, Ravikumar Garu, and one more important and the most well-wisher to always to me, Professor J.R. Babu Garu, and Professor B. Muniswami Garu, and other dignitaries, and also my USMS team, Professor Sujata Garu, Professor Kaneswari Garu, and Professor Ayappa Sastri, my close friend and well-wisher, and other all dignitaries and my dear students and various delegates from various places. Very good morning to all of you. Now, respected chief guest of today's function, Professor KPR Sastri Garu, honor, guest of honor, Professor GP Rajshekar Garu, Director of the conference, Professor Amrata Kamasri Garu, Convener and Organizing Secretary, Professor C. Srinivasrao, and myself, invited speakers, participants, guests from various departments, very delighted to organize this conference on behalf of the Department of Mathematics in association with the USMS and SMS. The main object of the conference is to promote and encourage research with application in the field of pure and applied mathematics and engineering mathematics, mathematical sciences. So this, in particular, this conference provides the platform for mathematicians in and around Uttarandhra with an exposure of recent developments. The initiation for this conference was from the chairman, USMS, Professor KPR Sastri Garu, the member of USMS. This international conference covers keynote speakers and the invited speakers from India and abroad. There are two keynote speakers from YJ Cho from South Korea, Professor of Emeritus attending online, and Professor GVR Babugaru, Emeritus Honorary from India. And the invited speakers are 15 from Nepal, Australia, and from various states in India, both attending online and offline. We have received nearly 250 participant registrations for the conference. We have received a huge response for the paper presentation too, out of which we accepted around 60 papers for presentation through online and offline mode. I wish this conference enriches all the young researchers and faculties in the area of pure applied and engineering mathematical sciences. I thank the university authorities for providing the opportunity of organizing this international conference, both with the finance support and the moral support. Thank you to one and all. Thank you.
Thank you, Srinivasrao. Next, we have message by Professor K.T.M. Sharma Garu, President of UASMS and Vice President of SMSMS.
Good morning, all of you. Respected chief guest of today's function, Professor KPR Sastri is a well-wisher of mine. The director of the conference, Professor P. Anuradha Kamasri, guest of honor, Professor J.P. Rajshekar, guest of honor online, Professor P.P. Murthy, convener and organizing secretary, Professor C. Srinivasrao, invited speakers, participants, guests from various departments. A very good morning on behalf of UASMS, Uttarandhra Society for Mathematical Sciences, and SMSMS, 20 Meenakshi Sundaram Memorial Society. I welcome you all to the International Conference ICPAEMS 2024. The Uttarandhra Society for Mathematical Sciences was established in the year 2018. Every year, the society organizes its annual conference at different locations of Uttarandhra. The present conference is the 4th annual conference of UASMS, organizing here in the Department of Mathematics, Andhra University. Coming to SMSMS, it's a society in the name of the distinguished mathematician Soti Meenakshi Sundaram. Professor S. Meenakshi Sundaram, between 1930 and 1968, known for his contributions in pure and applied mathematics. He is an internationally reputed mathematician who laid an important component in a new approach to Atiyah-Singer's index theorem, one of the greatest theorems of 20th century. His contributions to the Department of Mathematics, Andhra University since 1960 were pioneering. that the students and well-wishers formed a society on his name for prosperity of mathematics and has been a constant support in sponsoring activities of USMS and SMSMS. I welcome all the participants and wish to have a fruitful stay for all the delegates. Thank you once again. Thank you all.
Thank you, sir. Now I request our guest of honor, Professor G.P. Rajshekar Garu, to say a few words.
Very good morning to one and all. Respected Vice Chancellor in absentia and Chief Guest Professor Garu and Professor Sastri Garu and President and of Uttarandhra Mathematics Society, Professor Sharma Garu, Head of the Department, Professor Ananda Kameshwari, and the convener of this, Professor Srinivas Rao, and all the elder mathematicians, learned colleagues who are stalwarts present here today. It's my privilege to be here and participating in this conference. So it's a great initiative to combine these two societies. I attended in the past couple of conferences organized under the banner of Sri Meenakshi Sundaram Society. So with the general aim of these conferences to establish connectivity. One may say in this era, a lot of connectivity happening through online, etc. But for younger colleagues, it's very much required to interact and gain insights face to face. In my opinion, the conference is successful when younger colleagues declare on one of the days that this problem I have formulated during the deliberations of the conference and acknowledge the same in the manuscript. But that somehow is lacking. So we hope that happens sometime or other. So with the era of AI, ML taking this buzzword, the world ahead, I think as mathematicians, we also have equal responsibility to contribute to that. So right now, if you see, Government of India has announced 6,000 crores. You cannot imagine 6,000 crores for the quantum computing mission. So which contains a lot of branches of mathematics. So not only computer scientists, not only physicists, but the mathematicians can equally contribute. So recently there was a call to apply as a consortia for this quantum computing mission, and you can get a lot of funding. So that's one great initiative. And also there are National Center for Cryptography established at Kolkata. So these are all upcoming, which has hand in hand with the state-of-the-art technologies. Needless to say, AIML is there integrated on top of. So younger generation has a lot of opportunities. So it's you have to work hard, and then, of course, we as sciences a bit cornered. So no doubt about it, because most of the technology institutes and even the universities, a typical term is coined as supporting department, blah blah. So in this regard, my appeal to Andhra University authorities with the learned colleagues, I think AU should have one common math department, not pure math, applied math, stat, and then there is. So somehow this is a time that we show this strength. So that is one thing. And with the NEP 2020, National Education Policy 2020, I hope there might be a future where science is also encouraged, because now if you see, since I lived 23 years in east of India, West Bengal, there is no craze for engineering. They have a very strong BSc honors program. So today, if you go to IIT Kanpur chemistry or mathematics department, out of 60 students, 40 students are coming from east of India. So the teacher is totally confused what to teach. Why? Because 40 students have done BSc honors, and whereas 20 students, they have not done BSc at all. So through JAM, they entered. So when I say they did not do BSc at all, it's a routine BSc, no strong foundation, somehow JAM is cracked. So with less craze of engineering, east of India, producing a lot of bright science career experts, including mathematics. And what is the outcome? The outcome is today the premier institutes of the country, including R&D laboratories, is completely occupied with the scientists from east of India. So we need not be any sorry about this, because you are excelling and then you occupy your position. So that is lacking. So today the situation is science is somehow is buried under the ground, and then so we have to change it. So probably NEP is giving some scope. Why I'm saying it is giving some scope? So with NEP, student can study some verticals. So maybe a student who is having interest in physics, they will take some electronics and then study physics. So that scope may come. And as a society, parents, we have a larger role. And coming to the youngsters, yes, the quality of research, in between there was a dip, then again now slowly it's increasing, but still my appeal to the younger generation is there is no shortcut to doing science. So you have to do science the way farmer is spending blood and sweat to give us food. So unless we do science this way, we cannot excel, right? So enhancing quality of research publications, what we see is we are not focusing on the end outcome. That means the analysis and physical interpretations. So unless you spend time on this, we cannot enhance the quality of the manuscripts and compete with the international platform. So these are my few things for the younger colleagues. Once again, it's a great opportunity for me to be part of this stalwarts, and I am available. So for 2 days, so anybody is interested, so we can have discussions. Thank you very much, and wishing grand success of this conference.
Thank you so much, Ajay Kalyadu. That was quite informative regarding research opportunities provided by the Government of India. And the note you have given to all our younger research scholars to make use of this conference and move forward with some research from this conference. Next, I invite our chief guest, Professor KPR Shastri Garu, to deliver his message.
My dear friends, my dear friends, honored as Professor Roy Sacker, Professor KKM Sharma, and the head of the department, Professor Kameshwari, and my dear student, now Professor Srinivas Rao, in the Department of Mathematics, and all the days, so many dignitaries are there. Thank you very much for asking me to say a few words about this in this conference. Now, I want to say the genesis of UASMS and the story how the Professor SMS society has come into our hands. I was a student of this department. I joined this department in 1957 and studied up to 1960 and joined the department as a staff member in 1961. And I have a lengthy, long service and served the department up to 2000. During this time, what I find is that there are not many students coming from the Uttarandhra region. Always this is dominated by students from the Godavari Jilla districts and Krishna and Guntur. Why this? I belong to West Godavari district. I am not a native of this Uttarandhra. But however, this is pinching in me. So I want to have a platform for the students, scholars, mathematics pundits of Uttarandhra to say something, and to the people of Uttarandhra, we are not lagging behind. So I want to have a society first, to start a society first. And I have many students, of course, helping me in this regard, but I have two good, very good two students to me. One is the right hand, one is the left hand. That is Professor C. Srinivas Rao and Professor K. Sujata sitting there. And taking their help all the time, I discussed about starting the Uttarandhra Society for Mathematical Sciences. And they helped me, and they have undergone all the difficulties, and ultimately these Uttarandhra Society for Mathematical Uttarandhra Society for Mathematical Sciences come into existence. But it took a long time. I retired from the active service in 2000, but it took a lot of time to start this with the help of these two primarily, and others. There are so many people who helped me. But one unfortunate thing during this period is I lost one friend. That is who? Bhaskar. Professor Bhaskar. He was the treasurer of this one. Due to COVID, we lost him. A helping hand indeed. And now, since 2018, we are continuing with some breaks. And we hope to continue this tradition of holding the meetings every year. Maybe international, may not be international, maybe national, may not be national, maybe local, only to confined to only these Uttarandhra. That's my wish. I don't know how it will be, how will it be fruitful. Only time will decide. And these two people, my left hand and right hand, they have held the meetings of UMS and Professor SMS in St. Joseph's College, Mrs. in College. Now that Professor Srinivas Rao changed his venue to Andhra University, I am happy he is holding this conference in Andhra University itself, which I like very much. This is my parent department, so I am happy. This is about UEM, USMS, and you know the emblem, perhaps the emblem of USMS is not displayed here.
Yes, sir.
This is a small one. You see that this is Uttarandhra. These three parts, and this one resembling Visakhapatnam district. This is Vijayanagar district, and this is Srikakulam district. And these three colors have some significance. This is the industrial belt. Visakhapatnam is the industrial belt, and Vijayanagar is for arts, and there are pundits. And this is mainly agriculture. So that is how we designed, and he made this emblem. So I am grateful to him very much. Thank you, sir. Very much. That is how and you know something. This one. Uttarandhra Ganita Vijnana Varshad. You see that? I love Telugu. And I wish Telugu must be there in the emblem. And he honored my request and arranged for this. And I am grateful to him. Okay? And many people may not recognize what the emblem says. That is the little story about the UASMS. And the other one is Professor SMS, that society. Actually, I was a student of Professor S. Meenakshi Sundaram when I was here working here. But later, he changed his place and passed away. And some time later, I went to Hyderabad and some friends said, Professor Arunachalam is the key person, Srimati Girija, Professor Meenakshi Sundaram's daughter, and one Vani Prasad Rao. And they came forward to start a society in memory of Professor S. Meenakshi Sundaram. That is how they started the society at Hyderabad. Then, of course, I am also contributing for that one. They have the meetings. And in the meantime, they have become old. I am also become old. I don't say I am young, but I am younger to them. Therefore, actually, the Ramanujan Society or some society in Madras, they wanted to take it over, take this SMS society, which they are the people, Arunachalam, Bhavani, Prasad, and Prasad, Srimati Girija, they don't want it. Somehow it so happened that there is a meeting in Gayatri Vidya Parishad college, and myself, Professor Srinivas Rao, we went there. We have got report with them. And there, suddenly I saw Professor Arunachalam Garu. And he came to me running, said, Shastri Garu, you must do me some favor. What is that favor I can do? Because he is already well known. There are so many dignitaries who are ready to help him. But who am I? Or said, you must take over Professor SMS Society. Here is the resolution by the committee. There is no alternative. You take it. I was stunned. How is it that I only help the society, but I don't want to take the entire society into my hands. And another thing is that there is already one UASMS. So there are two things now. Whether I can do it justice to these two or not. Then Professor Arunachalam said, you must do and you can do, you are Hanuman here. So I thought I am Hanuman really. I took it. And Professor Srinivas and Professor Sujata, they are helping me all the time. So we combined. Whenever we have a meeting, it goes with Professor UMS conference together with Professor SMS conference. They go together. That's how we held some conferences. This conference also is like that. But there's something different holding the conference in Andhra University main campus of mathematics. We tried to have it in August. We could not. Then we want to have it in August because that was the birth month of Professor SMS. We cannot. There are so many reasons. And finally, Professor Kameshwari has come forward to move the papers to hold the meeting in the Department of Mathematics. So I am delighted with this. And Professor Srinivas Rao is already dead to help it, and Professor Sujata is there to help. So ultimately, this has come true. So I am grateful to these two people particularly, Professor Sujata and Professor Srinivas Rao, undoubtedly. Okay, sir. This is what I want to express before you all. Thank you very much. And one more thing I want to tell you, I have forgotten. I wish that the president of Uttarandhra Society for Mathematical Society must be from Uttarandhra, not from other place. And that's how Professor K.K. Sharma is inducted. Thank you.
Thank you very much, sir, for giving the details of the need for establishment and the process of establishment of the two eminent societies, UASMS and SMSMS, and your role in these societies to this August gathering here. Thank you very much, sir. Now we have small felicitation to both the guests on guests of honor and chief guests.
You should drop someday these days.
మళ్ళీ అవకాశం రాదు సార్ ఇలా రావడం కూడా I request all the faculty members to please, of the department, to please join in stating our chief guest and guest of honor.
Higher department honored.
Yes, sir.
Do have.
సార్ మీ చేతి మీదుగా గెస్ట్ ఆఫ్ ఆనర్ ఇద్దరికి
I have one.
Embarrassing.
Thank you, sir.
సార్ నెక్స్ట్ శర్మ గారికి సార్ మీరు మా గెస్ట్ ఆఫ్ ఎస్ అన్నారండి
Sir, please, sir. At the current page. Thank you. Sir, water.
మీది సార్
Sir,
ఇవ్వలేదు
Srinivas Master. Thank you.
సార్ వాళ్ళు next we have vote of thanks for this session by Professor M.V.R. Kameshwari.
Honorable Chief Guest, Vice Chancellor, Andhra University, P.V. J.D. Prasad Reddy garu, respected President, Principal of Andhra University College of Science and Technology, Professor K. Srinivas Rao garu, distinguished guest of honor, Professor P.P. Murthy garu, Department of Mathematics, Guru Ghazidas Viswavidyalaya, Bilaspur, India, Professor G.P. Rashekar garu, Department of Mathematics, IIT Kharagpur, West Bengal, India, Dr. K.P.R. Sastri garu, Chairman of UASMS and President of SMSMS, retired Professor, Andhra University, Professor K.K.M. Sharma garu, President of UASMS and Vice President of SMSMS, Honorary Professor, Department of Mathematics, Andhra University, the respected Director of ICPAEMS 2024, Professor P. Anuradha Kameswara garu, Head of the Department of Mathematics, AU, Convener of this conference, Professor C. Srinivas Rao garu, and invited keynote speakers, Professor Y.J. Cho, Korea, and Professor G.V. Ravindranath Babu garu, India, and speakers of this conference, Professor Anita Tomar, Professor Vasundhara Devi, Professor Dhananjay Gopal, Professor Hemant Kumar Nashine, Professor Vishnu Narayan Misra, Professor Ramesh Kumar Vats, Professor Ravi Kant, Professor Kenneth Jha, Professor Deena Sunil, Professor G. Nanaji Rao garu, Dr. K.N.V.V. Varaprasad, Professor K. Venkateswarlu, and other distinguished professors and delegates, ladies and gentlemen. On behalf of ICPAEMS 2024, I heartfelt gratitude to each one of you for gracing this occasion with your presence and making inaugural function a resounding success. We would like to P.R. Sastri Garu for his valuable insights towards the establishment of the SMS and USMS society. Thank you very much, sir. We would like to thank Professor G.P. Rajshekhar Garu for his valuable perceptions and highlighting the issues we need to deliberate during the conference. Thank you, sir. We would like to express our sincere thanks to Professor K.K.M. Sharma Garu for sharing valuable insights about UASMS and SMSMS. Thank you, sir. We want to express our big thanks to Professor P. Anuradha Kameswari Garu for enlightening about the department and the conference. Thank you, madam. We would like to express our deep gratitude to C.S. Srinivasa Rao Garu for sharing the information about the conference. Thank you, sir. And on the our sincere thanks to all other esteemed invited speakers. We are very grateful to you for your contribution to this conference. We are happy to express thanks to the staff members of the Department of Mathematics that has made this event a grand success through their motivation and dedication. We want to thank all the participants and delegates for their active participation and engagement throughout the inaugural function. We acknowledge the hard work and dedication of the organizing committee and volunteers who have made tirelessly behind the scenes to ensure the smooth execution of this event. Your efforts have not gone unnoticed, and we are truly grateful for everything you have done. We would like to express thanks to our sponsors and partners for their generous support. Your contribution have made this instrumental in making this event a success. We especially thank our technical arrangement team, light arrangement team, and our media and press. Last but not least, we want to thank all the attendees for their patience, cooperation, and enthusiasm throughout this inaugural function. And we look forward for your continued participation in the conference. In conclusion, we thank everyone who has contributed to the success of this inaugural function. Your support and participation are greatly appreciated, and we look forward to an engaging and fruitful conference ahead. Once again, I thank all your cordial cooperation. Thank you, sir. Thank you all.
In fact, we come to an end of this inaugural session. Now we will start our technical sessions. First is the keynote address by Professor Y.J. Cho on online. And for this session, we have our Professor G.V. Ravindranath Babu Garu, Honorary Emeritus Professor of this department. I request him to chair this session. Sir.
So nice of you. పెట్టాలి నాలాంటి
Sir, please unmute your mic, sir. Your mic was off. Sure, sir. Please unmute your mic, sir.
And unmute chair. Please unmute, sir. Message.
ఆయన స్క్రీన్ షేర్ చేయమనండి, అన్మ్యూట్ చేయమనండి.
Welcome, sir.
Yeah.
Welcome, sir.
Hello, Professor Babu.
We are not able to hear you.
Hello. Hello.
Yeah, sir. Voice is coming.
Okay. Hello. Hello.
Hello.
Namaste, sir. Namaste, sir. I am Ravindranath Babu speaking.
Yeah. I'm glad to meet you at the conference. Hello.
Yes.
Hello.
Hello, sir.
Hello.
Happy to
Thank
see
you. Thank
sir.
you very much for inviting me at this conference.
Very good. Very good. Welcome, sir.
Hmm.
Let us start this keynote address, sir. Welcome, sir, to this conference. The title of the talk is Some Algorithms with Line Research Rules for Nonlinear Problems in Hilbert Spaces. First, let me introduce you to the delegates, sir. It is
Can you see?
Sir?
Can you see the file of my talk? Can you see?
No, sir.
No, sir. No. Please share it, sir.
Can you see my file of my talk now?
No, sir.
No, sir.
Now?
Next time. Next slide. Please share the screen.
You.
Sir, are you sharing or we share?
Can you see the file of my talk?
No.
No, sir.
No?
Or we'll share, sir, from here. Your talk will share here.
Yes. Okay. Sir, yes.
Oh, yes, sir. Yes.
Can you see?
Yes.
Sir, open the presentation.
But open the file, sir.
Can you see my talk?
No. Only mail only we are able to see. Open the file, sir.
ఇదేనా సార్? సార్ ఇదేనా?
అదే అదే ఫస్ట్
Yes, sir. This is invitation. Schedule.
ఆయనే చేస్తారు. మెయిల్ పెట్టాను చూడు సార్, మెయిల్ పెట్టాను.
Professor Chu, good morning. Murthy here.
అదే ఎంతగా ఉన్నారు.
Sir, namaskaram.
చెప్పండి.
GR గారా?
Yes.
Good morning, good morning all of you. Sorry, అక్కడ రాలేకపోయాను నేను.
Morning, sir.
పక్కన శాస్త్రి గారా?
అవునండి.
సార్ నా నమస్కారం చెప్పండి ఆయనకి.
ఓకే ఓకే.
స్టార్ట్ అవ్వలేదా ప్రోగ్రాము?
స్టార్ట్ అయిపోయిందండి. ఇందాక ఫంక్షన్ కంప్లీట్ అయింది. ఇప్పుడు వైద్య చూడాలి.
లేటా కొంచెం ప్రోగ్రామ్ లేటా?
అదే వైద్య చూడాలి. కీనోట్
అదే చూసాను, షో ఉన్నాడు. అయిందా మొదలవ్వాలి?
ఆయనే మొదలవ్వాలి.
అదే ఆయనది మొదలవ్వాలి. ఏమైంది, లింక్ దొరకట్లేదా ఆయనకి? ఏంటి ఇష్యూ? ఇది ఆయన రూమ్ యాక్చువల్లీ.
연결이 안 돼가지고.
Professor Chu.
Hello.
Good morning.
Can you see the file of my talk?
No, sir, no. I can't see. I can see your email. Or you do one thing, Professor. You do one thing. You send the PDF to me. I will share this your document.
Your file.
Will send the PDF.
You send the PDF to me. I will share the doc. Don't worry. I will take care. You send me on my email ID. PDF.
Sir, it was sent to you, sir.
Yeah?
Through WhatsApp. It was sent to you through WhatsApp, sir.
Okay, let me check. Let me check.
공유하고 있는데
No, I
이거
did not.
그자서 메일이거든.
그 메일이 공유가 안 되는 거죠 지금.
예. 파일 요걸 공유를 지금.
Through WhatsApp.
Professor, so check your WhatsApp group. What is the issue? Yeah. Now it is visible.
Okay, sir. Okay, sir. Fine.
Now it is visible, and yeah.
이 화면이 크게 되려면
You enlarge
Yes.
it. You
We are
enlarge
able
it.
to see, sir.
화면이 크대요?
이 확인이 중지가 돼 있는
아니 공유 중지 누르면 중지되는 건데 지금 중지 안 하고 되고 있어요.
화면이 크게
좀 작게 돼야 되나요?
크게 화면을 크게.
크게는 방법을 모르겠어요. 이 안에서는 이게 아마 최대일 텐데. 이것처럼 완전히 여기 다 채우려고 근데 이거는 여기 안에 들어가 있는 거면은 이 화면이 이 정도 크기밖에 안 돼요.
이걸 숨기하고.
네네. 공유는 되고 있거든요.
요거는 내 사진이고.
Sir, we are able to see, sir. Now I wish to introduce you to the delegates, sir. I am starting introducing, sir. Professor.
Hello. Hello.
Hello. Hello.
Hello.
Hello.
Hello.
Hello. Hello.
Yeah, you are audible, sir.
나갔다가 다시 참여하시 이렇게 있네.
누가 호스트예요 지금?
진짜.
Hello. Are you able to hear me, sir? Hello.
여기 지금 그걸 해야 되나?
Able to hear
안
me?
되죠.
네. 나갔다 들어오면 다시 이걸 해야 되는데.
네, 다시
나가요?
나가게 해가지고.
Please share, sir, your talk.
근데 이게 화면이 왔거든요. 사람이 이상하네. 화면으로 돌아가네.
아까 그 회의는
새
지금 소리가 회의에서 하고 있는 거 아니에요?
하는데 이게 화면이 안 뜨지네.
지금
Hello.
Yeah, professor.
Hello.
Yeah, you are audible, sir.
We can hear you.
Okay, fine, sir. Then please share the talk, sir.
화면 공유하고 있다고 안 뜨는데. 지금 본 화면이 이게 공유되고 있는 거예요?
아니 여기 지금 공유를 해야 되거든요.
그렇죠. 근데 이게 공유됐는지를 어떻게?
సార్ మనం చేద్దామని చెప్పండి.
మనం షేర్
హలో హలో
ఆయన చేశారులేనా?
ఓకే సార్, ఫైన్.
여기 보이는 것 같긴 하거든요. 이 화면이.
It's fine, sir.
내가 보고 그걸 해야지.
그쵸. 그러니까 보셔야 되는 거죠. 이거 보시면서 발표를.
Now we are able to hear you, sir. What about you? We are able to hear you.
그럼 잠시만요. 이거잖아요. 그니까 여기에서 그냥 발표를 하실 거면은 그냥 이 화면을 보시고 발표를 하시면은 여기에 주면서 자동으로 넘어가는 것 같아요. 그래서 여기서 지금 이게 예를 들어 이 화면이면은 여기에서도 같은 화면이 뜨잖아요. 그래서 그냥 발표를 하실 때 사람들 피드백을 안 봐도 그냥 이것만 보시고 발표를 하셔도 저쪽에서 알아서 그다음에 화면은 보이고 들리고.
내가 요 귀 있거든. 여기 내가 발표하는 화면이 여기 뜨거든.
그쵸. 원래 그렇게 떠야 되는데.
이게 Hello.
You are audible, sir. Okay.
Hello.
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 I think your mic is off, sir.
이게 그게 안 되는데 이게 내가
지금 원하시는 게 본인 얼굴이 크게 뜨고 화면이 작게 뜨는 거 원하시는 거예요?
아니 요래하고 요 옆에 이 화면이 뜨고 그 다음에 내가 진짜 이야기하는 게 들려야 되거든 지금.
네.
그자 지금 안 들리는 모양인데 이 화면에서는.
아까 헬로 했을 때 좀 약간 작게 헬로 하지 않았어요 저기서?
Hello.
Yes, sir. Hello.
Can you see the file of my talk?
Yes, sir.
Now I can give my talk now.
Yes, sir.
Okay?
Yeah, okay, sir.
Right. Yeah.
Okay, sir.
Yeah, thank you very much for inviting me as invited to talk at the International Conference of Applied, Poor and Applied, and Engineering and Mathematical Science.
Sir, I'm very happy. Sir, please.
Hello?
Sir, please.
Yes, sir. Go ahead.
Okay. I hope to change next and next speaker now give a talk, and then next I give my talk. Okay.
No, sir. Now you proceed, sir. Now everything is okay, sir.
You can hear my speaking.
Yes, I am able to hear you, sir.
Okay. Yeah, okay, now I begin my talk now.
Yes.
Okay?
Sir. Fine.
Again, thank you very much for inviting me at the International Conference for Applied Engineering and Mathematical Science. Also, I'm very happy to give my invited talk at this conference. Now I am giving my talk entitled Some Algorithm with Line Search Rule for Non-Problem in Hilbert Space. In this talk, we consider the following. First, we introduce some motive for this talk for one example. Second, we introduce some definition and lemma. Fourth, we introduce some modified projection method with the line search rule for solving variational inequality problem, and relaxed CQ algorithm with the line search rule for split feasibility problem in Hilbert space, and prove some weak and strong convergence for proposed algorithm. Finally, we give some numerical illustration and some suggestion on convergence of modified projection method. First, I give motivation of this talk. First, consider function f defined by like this, then the global minimum of f is 1.1. Now, by using the following gradient descent defined by like this algorithm, we try to find the minimum of fx. First, 0, 0 belongs to this set and the initial point. Then, according to the choice of step size lambda, we have following cases. If we choose step size very good, and then the sequence converges to minimization problems. Second, if we choose small step size like this, the iteration at 20 iterate here start, not converge to minimization. Like this, if we choose big step size like this, after 20 iterate, some place like this fraction, not converge to 0. As in example 1.1, according to the choice of step size, the proposed algorithm can converge a solution of nonlinear problem or cannot converge to solutions. Thus, we use line search rule for proposing some convergent algorithm to solution of nonlinear problem. Second, we give some definition and the lemma for our main result. First, as you know, we already know metric projection like this. We have some property of metric projection as follows like this: A, B, C, especially property D. Projection metric projection is a non-expansive mapping, and the following property is very important. This we can see if we see fixed point of projection metric projection and the solution of variational inequality problems. Also, the mapping is said to be strong monotone equality. Alpha inverse strongly monotone if there exists positive alpha such that this inequality. Monotone satisfies the following inequality. Strongly pseudo-monotone if there is a number positive alpha such that this implication. Pseudo-monotone, this implication, this. Also quasi-monotone, this implication, this. Semi-strictly quasi-monotone, if the following condition hold, first A is quasi-monotone, B for some Z belongs to this interval, this implication, this. L receives continuous, a positive lambda such that this inequality. Sequentially weakly continuous if the weak convergence of a sequence to a point X belongs to H implies the weak convergence of AXN to AN. We have the following relations: strong monotone implication, monotone implication, pseudo-monotone, and quasi-pseudo-monotone, strongly monotone, like this implication. Also, a function f is said to be a weakly low semi-continuous at the point x belongs to h if for any sequence xn convergent weakly to point satisfy the following inequality. Serve gradient like this. Also, we have very important the following lemmas. H1, H2 be Hilbert space, C and Q subset of H1, H2 respectively. A from H1 to H2 is be a bounded linear operate. Consider function f defined by like this, and then we have the following. The f is convex and differentiable. The function is a low, weakly low semi-continuous function. And also f gradient delta f is as follows, like this. Very important property. The gradient delta F is 1 over A norm square inverse strongly monotone. Also, since proved the following lemmas, f of b function defined as in the lemma 2.1, let positive gamma x star belongs to H1, then the following statements are equivalent. Thus, x star solve a feasibility problem, the point x star solve a fixed point problem. The x star solve a variational inequality problem with respect to gradient of this means like this. Up here, we show the weak convergence of some proposed the algorithm. We use this lemma many times. Also, 2.4 Tan and Su introduced the following lemmas. Menge also introduced very important lemmas like this. And Menge also very useful lemma. Also lemma 2.7 also Menge introduced the following. This lemma is very useful to prove a main result. Also lemma 2.8 proved by Professor Su. Let AN a sequence non-negative real number, and there exists positive integer such that satisfy this inequality, where gamma and Bn sequence such that satisfy the following, and then AN converges to 0. Very useful to prove the main result by using lemma 12. Now I introduce some kind of projection method. 1966, the simplest projection method is Goldstein-Polyak projection method defined by as follows, like this. Step size belongs to this interval. A is L is continuous and strongly monotone. In general, the projection method can be used only for solving variational inequality problem, and the mapping A is L is continuous and strongly monotone. Here, strongly. If the monotone mapping A is monotone, not strongly monotone, then projection method may diverge independently of choice of step size. We give one example like this. To avoid the hypothesis of a strong monotonicity in projection method, Kopelevich proposed the following extra gradient method as follows, like this. Here, L is continuous and monotone, and the lambda belongs to this interval. In fact, in the extra gradient method, one needs to calculate two projections onto the closed convex set C in each iterate, which might seriously affect the efficiency of algorithm. It is very difficult to calculate this algorithm. Like this, closed convex subset, and like this, like this, like this, like this. But continuously to find x kn plus 2, kn plus 3, kn plus 5, it is very difficult to find this iterate like this, like this, like this. And so to improve Kopelevich extra gradient method in 2011, census introduced the following gradient extra gradient method. In this method, they have replaced the second projection in extra gradient method by projection on the Happen space Tk as follows, like this, Tk xk plus 1 equal p, like this, this Happen space like this. Also, A monotone operate. Step size belongs to this interval, like this. This Tk step size yellow regions here. But it is very easy to find the next iteration like this. And then this is very useful to converge a solution of variational inequality and other nonlinear problems. Recently, by many authors of gradient method has been received great attention and has been improved several ways for solving nonlinear problems. Especially Sejong combined the subgradient extravagant method and the Harpen method to propose an algorithm which is called the Harpen subgradient exgradient method for solving variational inequality problem like this. This finally iteration is called the Harpen iteration method like this x0 fixed point, one fixed point. Step size belongs to this interval. Beta k satisfies some conditions. Also, Tong et al. Introduced initial subgradient extragradient method algorithm combines subgradient extragradient method for initial method for solving variational inequality. This later iteration is called extrapolation, initial extrapolation like this. They use also like this Harpen spaces like this. This this viscosity iteration, man iteration like this, combined like this. This sequence converges strongly to a solution of variational inequality problem. We remark here some projection method may fail to be defined and the mapping F is not L receipt continuous or its receipt constant L is unknown since the step size dependent receipt continuous L. Next, I introduce modified subgradient gradient algorithm with line search rules. In this section, we introduced the following. Omega denote solution set of variational inequality problem. Okay, set. Also, the weak convergence of extra gradient method require the L received continuity of A or L received continuous. Otherwise, the extra gradient method fail to be defined since the step size lambda dependent L receives continuous. To overcome this problem, 1992 ICPAEMS introduced a new extra gradient method with a line search rule to obtain step size. But to apply line search rule can be very computationally expensive in some algorithm. For example, CPU time is a little long and long. ICPAEMS algorithm is as follows. Initialization, this constant conditions, iterative step like this, first computer like this, alpha n step size satisfy the following conditions. Xn, if Xn equal Yn, and then stop, and the Xn is a solution of variational inequality. Otherwise, you go to step 2. Second, computer like this, where beta n satisfy is like this, set n plus go to step 1. Recently, Khan et al. Proposed modified the subgradient gradient algorithm with line search rules like this. They use like this Harpen space, okay, here, and this man iteration. Here, lambda step size lambda n satisfy this. Their algorithm does not need prior knowledge of receipt constant L of the mapping. Furthermore, Kai introduced also modified the subgradient exgradient algorithm with a line search rule as follows. They also use Harpen space. Also, they use viscosity iteration. F is a contradiction mapping here. And here, lambda n satisfy the following inequality. Under the assumption pseudo-monotonicity, they proved that the sequence action converges strongly to a solution of variational inequality problem. She proposed also modify the initial extra gradient algorithm with line search rule as follows, like this. This initial extrapolation iteration here. If we add the initial extrapolation and then a little more very fast converge to a solution of variational inequality problems. Also here lambda n satisfied the following conditions. Also they proved the sequence xn converges strongly to a solution of variational inequality problem. Also let M pseudo-monotone uniformly continuous and the sequentially weakly continuous mapping in case tan at all introduce or modify subgradient extra gradient algorithm with the line search rule as follows, like this. They use like this initial extrapolation. Here phi satisfied the following condition, and the second like this, and they also use a Harpen space Tn. Also lambda n satisfied the following conditions, and the computer like this man iteration here, and the three-step iteration. In next section, we compare this kind of modified extra gradient algorithm with some line search rule, our algorithm like this. Next, I introduce a golden ratio algorithm with the line search rules. In this section, we introduce modified golden ratio algorithm with the line search rule for pseudo-monotone variational inequality problem with non-reception mapping and prove some strong convergence under some appropriate condition in Hilbert space. Finally, we give some numerical experiment to illustrate performance and advantage of the proposed algorithm like this. G, proof convex low semi-continuous function with a domain like this. Recall the proximal rate of G is defined like this, okay, like this. Set the pi root pi plus 1 over 2 golden ratio. This means like a solution of this second. Marisky proposed a new algorithm which is called explicit algorithm for solving variational inequality problem. And F is locally received continuous as follows, like this, xn like this proximal like this. In this iteration, by explicit, we mean that method does not require a line search rule to be run, and its size are computed explicitly using current information about its rate. Recently, Hugh and I introduced golden ratio algorithm with a sequence of step sizes such that like this being diminishing. This means step size converges to 0. Otherwise, alpha n step size converges not non-zero constant lambda positive like this. The use of this new step size rule allow algorithm to work without previously knowing the received continuous received constant of cost operate as follows, like this. Algorithm, first one, golden ratio algorithm with diminishing, this means step size converges to 0. Like this step size satisfy this condition. This condition are very well known. Iterative step assume that xn x known and calculate xn plus 1 as follows, like this. And algorithm. Hello? Hello? Algorithm 2. Hello?
Yes, sir. You are audible.
Are you okay? Okay, my talk okay? Hello?
Yes, sir.
Okay, no problem.
Yes.
No problem,
Can
sir.
you hear? Can you hear my speaking?
Yeah.
Yes, sir.
You can see the file of my talk.
Yes.
Yes, sir.
Thank you. The second golden ratio algorithm either of this 6 steps.
10 minutes more. Please complete by within 10 minutes, sir.
What do you mean?
10 minutes. Time.
10 minutes.
Yes, sir.
Yeah, okay. Second, not to convert to zero in case like this. Okay. Now we introduce initial subgradient extragradient algorithm line search rule for solving variational inequality problem. Assume F is contraction mapping with constant rho and alpha n is a sequence belongs to this interval satisfy these conditions. In order to obtain convergent result of our algorithm, we need the following: variational inequality solution set non-empty, feasibility set non-empty closed convex, the mapping F pseudo-monotone sequentially weakly continuous and uniformly continuous on bounded subset. And we introduced the following initial subgradient X-gradient algorithm line search rule like this. Okay, here initial extrapolation and like this. Second computation like this, London step size satisfy the following condition. So we use Happen space like this. This viscosity iteration here. Okay. Now we compare our algorithm, the following algorithm like this. Can introduce algorithm 3.1, Chi 3.1, C introduce algorithm 3, and algorithm 10, algorithm 22. Okay, like this, we can see the initial illustrate numerical illustration like this. Our algorithm, red algorithm like this. We can see like this, Okay, if you want to get the file of my talk, I send you the file of my talk and the many paper on this coming topic. Please let me know by email, and then I provide all file of my talk and another many papers. Okay, the talk time is very short, and so I cannot see. I can give all my talk this time. And then if you copy the file of my talk, and if you have any question for my question, anytime, please let me know by email. And then we discuss our common topic problem, okay? Like this, we can compare here blue colors. Our algorithm is very quickly to converge a solution of variational inequality problem like this. We give some examples by using our algorithm and compare other algorithm together. And then you can see in these pictures, our algorithm very faster than others. Okay, 7, split feasibility problem. Also, consider the following split feasibility problem, which formulated as follows like this. Okay. X star, okay. From split feasibility, we have the following. Q is a singleton. Then we have a convex constraint linear inverse problem from the split feasibility problem like this. split feasibility problem, like we can see the pictures like this, and then you can understand the split feasibility problem very easy. And H1 equal H2, A equal identity mapping, the split feasibility reduced to the well-known two-set convex feasibility problem. The problem, split feasibility problem can be reformulated as the following constraint minimization problem. Due to this reformulation, Bayer introduced CQ algorithm, which is based on gradient projection method like this. The split feasibility problem first proposed sense in Euclidean space from a split feasibility problem. We can give some application in our real life, such image reconstruction, signal identity, and many others. We introduced some relaxed CQ algorithm. First, originate algorithm, which is introduced by sensors as follows, like this. Sensor algorithm involve computation of matrix inverse A inverse, assuming the existence of A inverse A, and so not become very popular. To improvement of sensors, Bayer introduced the following CQ algorithm like this. At that time, in CQ algorithm, Bayer assumed that the projection PQ and the PC are easily calculated. However, later he knows that it is impossible to or need too much work to exactly compute orthogonality. Okay, first time Bayer assumed two projection can be calculated, but it is very difficult to calculate two metric projections. To overcome this difficult, Fukushima introduced the level set C1 and C like this set, Q like this set, okay? And Yang presented the following relaxed CQ algorithm to solve a split feasibility problem like this. Here, CQ and QK introduced as follows like this, okay? It is seen C subset of CQ, Q subset of QK. Also, recently, Kibali et al. Introduced modification of relaxed CQ algorithm by using line search rule for solving split feasibility problem. For which define a mapping FK like this, and then we have like this gradient like this. Kibali introduced the following like this. AK satisfy this following condition. Next, construct iterator xk plus 1 by like this. Very simple. And recently, Xuantai also I introduced the following. And next, on the other hand, consider the following convex minimization, where f defined like this, and then we have the following. The gradient of f is like this, function convex and the differential gradient is a norm to receipt continuous. The following gradient projection is the most effective method to solve convex minimization problems like this. From this, we know Bayer CQ algorithm is a special cases of gradient projection method. Nevertheless, efficient of gradient projection algorithm depends greatly on the choice of step size lambda. For example, small step size lambda guaranteed the convergence of iterative, but the recursion lead to slow speed convergence. Otherwise, a large step size random will improve speed convergence, but generated sequence may not converge real application for solving variational equality problems.
Please.
Overcome this difficulty, so called self-adapt method which permits step size being selected self-adaptively was developed like this. Okay. Now we introduce the following the initial self-adapt and Cason Prom introduce CQ algorithm like this. Dong et al. Introduced the following initial self CQ algorithm for solving split feasibility problem like this. Recently, I and my friend introduced initial self-adapt gradient algorithm like this. Okay, like this, step size like this. Here, initial extrapolation here, and the computer run them like this. And the computational result for proposed CQ algorithm, we compare like this, introduced by Lopez and Kibali and Caspon and Dong. We compare these algorithm with our algorithm. In survey, we like this in figures. You can see our algorithm is past converged to solution of a split feasibility problem in Hilbert space in case.
Sir, please conclude, sir. Please, the time is completed, sir. The allotted time is completed, so please conclude your part, sir.
Recently, I and my friend introduced the following general initial man iteration as follows, which is called two-step initial. Recently, most authors introduce one-step initial extrapolation some iteration. In these papers, we introduce like this two-step initial iteration. We compare one initial extrapolation and with our algorithm with the second step initial extrapolation. Our algorithm tries to converge to a solution of variational inequality and split feasibility problem. Here, like this.
Sir, please conclude, sir. The time is over, sir. That's why. Please conclude, sir. Please conclude, sir.
Recently, also, Dong and I introduced a multiple step initial chronometer schema algorithm as follows, like this, multiple. We have many special cases of initial algorithm, okay, like this, many algorithm, okay. And I propose the following suggestion: two-step initial extrapolation like this, plus projection method and the relaxed CQ algorithm. And then we can propose some new two-step initial projection method and the CQ algorithm. This plus this algorithm, and then we can propose many kind of some new two-step initial projection method and the CQ algorithm like this.
Sir, please conclude, sir. Sir, time is over, sir. So please conclude, sir. Please conclude. Please.
Now I can give my talk more. Stop here.
Sir, please.
Stop here.
Please concluding remarks, sir. Please give concluding remarks.
Finally, I give my comment here. Okay. And then I give.
Okay, sir.
I will start very soon to give my talk. Okay.
Okay, sir. Okay, sir.
Okay.
Okay, sir.
Professor Babu.
Okay, sir. Sure, sir.
Okay.
Okay, sir.
Very shortly, I start to give my talk.
Okay, sir.
Okay. Yeah. And football field here. Okay. Here A, B, C, D, E, G, F, initial point. Okay, initial point. But in this penalty kick in case, it is very easy to make a goal. Okay, but PE initial point in case the iteration like converge to solution of a nonlinear problem like this, also like this, also this. But many authors introduce many kind of iteration with the initial point A, B, C, D, E, like this, by using CQ algorithm and the man iteration, Harpen iteration, viscosity iteration, many kind of algorithm with the initial point like this. But we choose appropriate step size and then many kinds of algorithm converge to solution of variational inequality and split feasibility problem and many others nonlinear problems. Okay, but corner key in case. Okay, one time kicker. It is very difficult to make a goal. Also, initial point, the G point, all same. Okay, we try to find very good algorithm at like this initial point. At the initial point, G point F, how to make a goal very quickly like this. Other initial point in case earlier, it is easy to show convergence of solution of many kind of nonlinear problem, variational inequality problem, split PG problem. But at the initial point G, F in case, it is very difficult to make a goal. Okay, and now there is no best one algorithm to converge solution of a nonlinear problem. Best, no best. But now many authors try to find best algorithm. Every year, many authors introduce many kind of new algorithm to converge solution of a variational inequality problem and split PG problem and many kind of algorithm. But at like this initial point G, F in case how to find very best algorithm to make a goal like this by very quickly. Okay. Finally, I give some suggestion in my talk section, 11 sections. You can see many kind of open problems there. If you want to get my file anytime, please let me know. I send you the file and related many papers to you. Okay? Okay? Okay, now stop. And if you any question, and please let me know by email. But my English is a little poor, and then I cannot understand your English. And so anytime, please let me know by email, and then we can discuss our common problems related to my talk and the other fixed point sharing. Okay?
Okay, sir.
Thank you very much for attention my talk. Thank you.
Thank you very much, sir. Any questions, delegates? Any questions if you have, you can ask.
Yeah, I'm sorry. I have no much time to give my talk, but my talk maybe 142 pages.
Oh, lengthy, sir. Very lengthy it is. Too lengthy.
Yeah. Thank you very much for inviting me as invited to talk at your excellent conference. Thank you very much. Professor Babu also introduced me. Thank you very much, Professor Babu.
Thank you,
my friend.
Thank you for valuable time to our delegates, sir.
Yeah, thank you so much.
Very happy to see you, sir. Okay, sir. Thank you very much.
Bob, I sent you the file of my talk. You send all participants of this conference. You send all file.
Sure, I will send to all.
Yeah.
Thank you very much, sir.
Yeah, thank you very much again.
Thank you. Fine, bye, sir. Bye.
I'm sorry. My English is very poor.
Okay, sir. It is with me. Okay, sir. Fine. Bye, sir. Thank you. Bye.
Now,
Thank you, sir. Now I invite Professor K. Rajendra Prasad Garu to take the session of invited talk one. I welcome to Kanihaja. Professor Kanihaja, sir. Thank you, sir.
Good afternoon, sir.
Good afternoon.
Professor Kaniyaja, welcome to the conference to present your innovative talk. Let me introduce briefly regarding you. So, Professor Jha is working in Department of Mathematics, School of Sciences, Kathmandu, Nepal. And his researches are so many areas are there: functional analysis, fuzzy mathematics and its applications, convex analysis and its applications, number theory and cryptography, mathematical model. He published more than 57 papers and he guided many students for their PhDs and MPhils. Now I invite you to present your talk. So we have half an hour time, sir. The talk title is on some developments of metric fixed points results. So please present your talk, sir. Sir, are you able to hear me? Okay. Sir, are you able to hear me?
Yeah, I'm listening, but I am not able to connect my file. That is the problem. Just 1 minute, please.
No problem.
One message itself. Thank you so much, sir. Department of Mathematics. వస్తే బాగా సంపాదన లేనప్పుడు ఇలాంటివి అడుగుతాం బాగా సంపాదిస్తే
ఇంట్లో ఉన్నారా మీరు ఏం కాల్ చేశారు ఉన్నారు మీరు ఇంట్లో
Screen is shared కదండి. He is trying to share this. Is it possible to make a big screen? Or is it better?
Are you listening me?
Yeah, we are able to listen you, sir.
Yeah. So is it, are you getting my slide?
Not clear, sir.
Not clear?
You may open the PDF file.
Are you not getting my slide?
It is directory. Open that file, sir.
So are you not getting?
No, sir. So please open the file and share with us.
Yeah, that I have made it right now.
You are seeing the desktop stage.
Open the screen, sir. We are able to see you. We are able to hear you. Please share the screen.
Are you able to get it or not?
No, sir.
No, yeah?
Sir, before we have seniors sharing, sir, we just need to open the presentation. Again, reshare it, sir.
I have already opened the file, but when sharing, it is not seen, I think. Yeah. There is some problem. Just
Sir, just open the screen sharing option, sir. What you done before is exactly correct, sir. Just open the screen sharing, sir.
ICPAEMS నుంచి జాన్ అందరి
Yes, sir, we can see your screen now, sir.
can you see now?
Open the file. We can see the.
Is it?
Yeah. Okay.
Okay, yeah.
So is it possible to go to full screen?
Can you see? Can you see my file?
Disappeared.
Excuse me, can you see my file?
No, sir. Full screen చేయమంటే full screen చేయమంటే it's okay.
Babu, full screen. Is it okay now? Are you getting my slide?
No, sir. Previously we are able to see you, but now it is not visible. Share it. Please share your screen.
Is it okay now?
No.
Babu.
Yeah. Screen is, you are able to see the screen, but presentation is not there.
Open the one.
Oh yeah, it's good. Okay, you can start, sir.
Is it okay now?
Yeah, okay. Please,
Okay, thank you very much. Sorry for the delay. Yeah, first of all, I would like to thank the organizer for giving me to this beautiful conference. Lots of memories are there with the Babu, PP Murthy Sahab, and I cannot forget the KPR Sastri Sahab for their support through in the beginning of my research activities. Maybe my topic is some development of metric fixed point results. So right now we have seen many work of Professor Cho as the application. So with this, now I want to start my presentation. My presentation is very elementary. I am not showing any sort of abstract theorems or results, but I want to share some of the domain where we are working in Nepal. So now we have very good team of fixed point results, and it is the support of Professor Y.J. Cho and KPR Sastri Sahab in the initial stage. And still now we are getting full support from Y.J. Cho. Now we start with the following questions. When we are working in the fixed point results, then why do we need fixed point notions? So the main purpose of our work is to solve function equations. So automatically we have many methods. The bisection method is there, Newton method is there, and nowadays we are working on the fixed point methods. So my plan of presentation is maybe due to time constraint, I will skip this basic notions. Then the main source of research activities is Banach contraction principle and automatically generalized Banach contraction principle. Then we have many generalized forms of Banach contraction principles where we have the research domain. We have many new generalized forms of metric space. And then there will be resources with some informations. So now I will skip many of the basic parts that I had included in my slide to present. So most of the mathematics is focused on the solution, and that is whether we are working on the exact or approximates of various equations involving numbers. So this is the way how we solve algebraic equations in the numerical methods, but algebra has its own constraints, so it is not always easy to get solution in the field. But the nature of the solution of the problem to the problem always help to analyze the system, solvability, stability, and smoothness. Just now we have seen good example of minimization problem in Hilbert space. So thank you, Vajicho, for sharing such a nice work. So if X is a Banach space, so we find many applications in Banach space. Then the problem of solving a functional equation is to reduce it into fixed point theory. So any result on the fixed point problem, T of X is equal to X, can be rephrased as the result of the equation f of u is equal to 0. So this transformation is very important to find the solution in the nonlinear systems. And as Vajichu has said, that we are always looking for the best solution. Best possible solution is our target. So this is the many equations which are of interest in applications can be put in the form of T of X is equal to X, where T is the self-mapping of the metric space, and a point X which satisfies this function equation is called a fixed point of the mapping T. And this is very elementary tool in case of numerical analysis. Now I am skipping many basic terms due to time constraint. When you talk about the nonlinear analysis, then automatic approaches, one is the fixed point theory, that is the classical approaches where I am working. Then we have another part, that is the approximation theory. And the third part is variational inequalities. So the work of Vaijutsu just said is basically the part of variational inequality. My work is related to fixed point theory. In case of fixed point theory, it has divided into three major areas. One is the topological fixed point theory, metric fixed point theory, and discrete fixed point theory. Even among these three, my work is based on the metric fixed point theory. So I will talk more about the metric fixed point theory, where we have our own domain. In case of metric fixed point theory, we have Banach contraction principle, well-known Banach contraction principle. So in metric fixed point theory, we have the contribution from the Lovelace, Picard, Banach, and Gobel. So now I will move to the Banach contraction principle, and that was given in it is the main source of our research in the metric fixed point theory. So let T be the contraction mapping. Maybe all of you are familiar with this one. Let T be the contraction mapping on the complete metric space. Then T has unique fixed point. That can be changed to the contraction condition, that is distance between Tx and Ty is less than or equal to K of D of xy. So this formula is very useful to have contraction condition, and contraction condition is necessary to have convergence criteria. And in numerical method, we have this sort of iteration, that is xn plus 1 is equal to T of xn, and on the basis of this formula, we have many sort of. Similarly, for the application point of view, contraction of T is more stronger than the continuity. It guarantees the existence will also provide a method to compute the fixed point as well as for the. for the application point of view. Now, it guarantees the existence and also provides a method to compute the fixed points as well as for the error estimates. But in case of Banach contraction principle, it has lots of conditions to apply, like contraction should be there, completeness should be there, and both conditions are necessary conditions. But it is very interesting for the application point of view because it is constructive result, and so it has wide applications to other disciplines. Then after J. Chomsky, Schroeder, and Stein in 1999 established the generalized Banach contraction principle, and this is the formula where we have the minimization of the distance d of ti of x, tj of y. So this is the generalized Banach contraction principle. So automatically Banach contraction principle is the particular case of generalized Banach contraction principle when p is equal to 1. In fact, the theorem generalized Banach contraction principle is not true for all natural p, but true only for p if t is uniformly continuous. So this is the open research. If p is equal to 2, then we have the result is true without any additional condition. If p is equal to 3, then we have the general Banach contraction principle is true with the additional assumption that t is continuous on x, and automatically the continuity condition is the stronger condition to establish the fixed point results. Now, this slide is very important for the new research scholars who are interested to move towards fixed point theory. So the necessary conditions in Banach contraction principles are contraction for the single self mapping and completeness of metric space. Now we have the following sources. If you check the completeness of the metric spaces, then we have more than 15 subspaces, generalized form where we are working. I will list the subspaces or generalized metric spaces. Similarly, the Banach contraction principle is related to single self mappings. But what happens when you are approaching to the pair of self mappings or two pair of self mappings or sequence of self mappings? This is another domain for the research activities. Then again, we have the generalization of contraction condition because we have to replace. If you move to the pair or two pairs of sequence, then automatically contraction condition is not sufficient to take the guarantee of fixed point. So you need more contraction conditions, additional conditions on the pair of mappings, and we have more than 17 plus fixed point results with applications. This is another domain where lots of other sciences, non-mathematical sciences are working there to get applications. So automatically the title of this conference is very interesting because we have both pure, applied and engineering mathematical sciences. So this notion is very applicable to application point of view. Now, if you see the contraction condition, then we have the Banach contraction principle that was in 1922. Then we have Kannan in 1968. Mead-Killer type contraction condition. This was the main source when I was in the PhD work under the supervision of Professor R.P. Pansab at Kumaon University. Even we have the weaker form of Mead-Killer type contraction condition. So my PhD work was basically focused on the weak form of Mead-Killer type contraction condition, and I could able to establish some of the results with this condition. Then we have Wide-Wong type phi contraction conditions. Then we have some implicit relations also we are working there. In some cases, we need property EA for the non-compatible mappings. Now, then we have Rich and I.A. Roos, both gave the condition, generalized the above Banach contraction to three constants A, B, and C. And finally, Chatterjee also gave in 1972 this condition, and this is similar to condition of R. Kannan. Finally, in 1974, Tudor Jam Firisco from Germany modified above conditions to this one. Here, all three constants A, B, and C are in the functional forms, and the sum of these distances should be less than 1. So if you compare all these contractive definitions, then this is the most generalized form relative to the other contraction conditions. So these are the results relative to contraction conditions. Now I will move to generalized metric subspecies. So with the help of Imdad Saab, we have a team working on the semi-metric space that was in 1942. Then with the help of P.P. Murthy Saab, now I have seen him, and the Ismat Beg Saab from Pakistan. Now we have a team working in the probabilistic metric space. I am very lucky to see KPR Sastry Saab, whose paper in 2002 motivated me to move towards fuzzy metric space. In his paper, he has claimed that can we replace continuity to the reciprocal continuity? And at that time, I was the research scholar, and with the blessings of him, I could able to give the answer and published it. Thank you very much, sir. So his blessing is connected to my research activities, and now I am working in the fuzzy B metric space. That is the most generalized form of the fuzzy metric space. Then another group is working in the dislocated metric space. So if you see, then we can find more than 15 generalized forms of metric space where we have the common domain now. Now finally, I want to share some of the resources. That is, one book is from Joshi and Bosch. Another paper, this is very useful paper. All papers you can find Agrawal, Bist, and Sajad, who have established a paper where you can find more than 43 contractive conditions to establish fixed point results. I will share this slide to the Srinivas Rao Saab, so you can share it to all interested parts. Automatically, YJ Cho has given one survey on metric fixed point theory and applications that is very beautiful. And it contains many open research problems. So that is the source of the problem books, open problem books in fixed point theory. So just I want to share these 4 resources that can be helpful to the others to move forward. And finally, I want to share one event that is going to be in Nepal in 2025. So we are going to organize international conference on nonlinear analysis and optimization together with a workshop on fixed point theory and applications. So now it has been approved by our university. So Kathmandu University, where I am working, is the main organizer. Then we have the Tribhuvan University and Nepal Sanskrit University as the partners, where we have a team who is working on the fixed point theory and applications. With this, I thank you all for giving me and inviting me to this beautiful conference. I wish all the best for the success of this event. Thank you very much.
Thank you, Professor John. Any clarifications? Otherwise, you may contact directly Professor John. We will give you advice. Thank you.
Thank you very much. Namaskar to all.
So now we are fixating Professor K. Rajendra Prasad, sir. Sir, please. Next, invited talk to by Professor P.P. Murthy garu. Now I invite Chairperson Professor P.D.M. Srinivas sir. Please chair the session of P.P. Murthy garu.
Yes. It's my distinct pleasure to introduce our speaker now, who is Professor P.P. Murthy. He is a professor of mathematics from Department of Pure and Applied Mathematics, Guru Kasidas Vishwavidyalaya, Central University. Professor Murthy's research areas are metrics, fixed point theory and applications, fractals, and dynamical systems. He has got more than 30 years of teaching and research experience. So far, he has guided 4 scholars for their PhD. He has published so far 67 research articles in journals of international review. He has also taken part in 41 conferences so far. He has visited several countries for collaborating with other experts. To list a few, he has visited Italy, he has been to Ethiopia, he has been in Thailand, he has been in Turkey, South Korea, France, and the United States. He is also a member of several professional scientific bodies. To list a few, he is a life member of Indian Mathematics Society, he is a life member of Allahabad Mathematics Society, and he is a reviewer for many international journals. With this brief introduction, I request him to kindly talk on the topic, some interesting fixed point results and applications. May I now request Dr. P.P. Murthy to share his views on this topic.
Yeah, good afternoon, Professor P.D.M. Srinivas garu, Honorable Professor, retired Professor K.P.R. Shastri garu, my warmest regard. I can see the Srinivas garu also behind you, Madam also there. On the screen, my very old and dear friend, my collaborator, Professor Yulji Cho from South Korea, Jeonju, Korea. Kanhaiya Jha, Professor Kanhaiya Jha from Kathmandu, Nepal. I think we met after 98, we never met so far personally. And all the esteemed members of the conference organizing committee of this Department of Mathematics, Andhra University. I think already everyone is getting late. I'm ready to share my whole screen because a lot of actually information on fixed point theory and applications done so far. So for the past several years, I am working on cryptography also. Cryptography and programming part of the computer science, that is the computational mathematics. And in the recent past, I am working on the data science. Since a lot of things spoken about the fixed point theory, and my interest was to come over there and write on the whiteboard and explain so many things on the fixed applicational part of the fixed point theory, but it was not materialized due to several reasons, and I should apologize for that. Let me share my screen, and I want to speak or some pass on some information on the data science, if you permit me, sir. Because a lot of things already on the fixed point theory. So if you say yes, then I will speak on data science, which is very highly informative And I hope that now is the right time for the people of mathematics who can switch over to data science along with their own specialized area of research. I'm failing to share. Earlier I was ready to share, but now I'm not ready to share. Let me share the whole window. Entire screen. Yeah, I think I am not allowed to share, sir. Please ask the administrator to allow to share the screen. Yeah.
He's unable to share.
Yeah. I am not able to share because everything is open.
Yeah, the permission is being given, sir.
Yes, sir. Yes, sir. Because in the entire screen also, yeah, I can't see my PDF and other things on the entire screen because not allowing to share.
The permission is done. Kindly have a look, sir.
Yeah, I checked. I'm checking also, sir, but not. Yeah, not allowed.
Still?
Yeah, still not allowed.
The administrator says that he has given the permission. Could you please check again?
Because if I share, then I can share only my this. Okay, let me off other things also. Let me except the Google. Nothing is on my screen except your drive. There is nothing on my screen, even though is not allowing. Yeah. Yeah, that button is not working, sir. Entire screen, yeah. In entire screen, I can only share the, yeah.
Entire screen it seems.
Yeah, in entire screen, I can share the screen.
Sir, everything is clear from my side, sir.
Let me. Can you see this now?
Yes.
Yes. It is visible now.
Now this is now screen. You can see the screen, right, sir?
Yes.
Okay. Thank you very much. Thank you very much. Yeah. Let me speak about the data science and applications. And as I said, that for the past few years, means for the past 7-8 years, I was working on the cryptography and in particular on the area of the public key cryptography, means on the security system. Parallel to the fixed point theory, and recently I am putting myself slow down on the fixed point theory and application, accepting few research scholars only on fixed point theory, and I am advancing myself either on the cryptography or in the data science. Right now I have one PhD student on data science and on data science side. And we are having some collaboration also with few people of our own region, IITs and triple ITs, and some people from the out of our country. So what exactly the data science we do mean, and what is the motivation behind that? The motivation behind the data science is right now the research what I can find around us in the real life situations. And in the real life situations, we can see that what kind of development is going on when you use any browser also, and even when you use the Google or when you are using the WhatsApp, etc. And you will see that particularly in the WhatsApp one-to-one encryption we call about, and this one-to-one encryption is nothing but the part of the cryptography. And as in the current trend, everything is online. Even the banking system is also online. So we can say that one day will come when we are talking about the no hard copy of the currencies, only soft copy of the currency. But I don't think that is possible actually. But anyway, we are trying to move towards that, how to strengthen the security system of this one. And for such things, the data is also needed, and data is not the one day one. This is since a long time we are collecting the data. Earlier, the data was in terms of a particular kind of data, and now these days the data is various type of data. You can find not only in bits and bytes, but you can find the pictures also. That is also comes under the data. And this data science is not only related to the computer science and engineering people. This is the main 60 to 70% part of the mathematics people, because a lot of logic is involved, lot of algorithms are involved, means a lot of analysis is there, and a lot of mathematical statistics we do use here, and some insights we draw. For the insights we use the regressions also. Okay, for the linear is fine, for non-linear also we are going towards that also, that how to draw the insights of the given data, and what exactly the solution we can provide to the industry side. So you can see here, this kind of data is now huge data is available in the world, and even in the website also. So these are some information regarding to the data, that data science is how the data science is helping us, and not only in the computer science and technology side, but this is helping towards medical also. This is working towards the finance also. This is enhancing the intelligence among us also, and it is supporting us. Even a student without teacher trying to learn from the information what is available in the website. So this is what I can say, that surprisingly about the data, what data is available in the web. But the question comes about this. So you can see here what are exactly the components of the data science. You can see left hand side, topmost left hand side. You can we can talk about the statistics, and in statistics you can find we use the measure of central tendency. Then we talk about the dispersion part. We talk about the curve fitting. We talk about the correlation regression. We talk about the this theoretical distribution also, some test also, and all such things are part of the statistics, and these are very important part. For the second part, you can see the domain expertise is there. Then you can find here what exactly the data engineering is. Then you can come here the advanced computing side. Okay, and this side is also visualization. So what I mean to say, that one should have to learn like the earlier days, C programming, C++ programming, and Java, and some people they are fond to learn the VB, then RDBMS, that is SQL and PLSQL both. Okay. So, but now these days there is a new emerging area of the language, and which is very popular, and is easier to learn when you compare with the other languages, and that is the Python programming language. Okay. So you can see that how this language is helping to the people to understand the programming and many other things. I'm more concerned about the data, so I'm talking about in that context only. So when you talk about the machine learning, then come to the deep learning. Okay. So in such a scenario, definitely the Python programming is very important for insights and other things. You require the R. But now these days, even you forgo the R by inviting the this Python libraries, you can skip R programming language, and you can have the insights by using the Python programming language itself. Then these are a few things that is statistics part, as I said. Then you need the visualization, because when we look into the data and data's visualization, for example, I think now these days everyone is interested to know about the score and other things all of the T20. Before that, in 2020, we already suffered from the COVID, and during the COVID, how the COVID virus spread towards the society and how we overcome from that also. Then there are a few more things also, that is the machine learning and the deep learning part. For this machine learning also, the mathematics people with knowing the little bit mathematics, they may go through also, and this is not a very difficult part because of the logical ability, and as I said, we have the good analytical ability, so we can understand this machine learning part also. Since we are all involved with the research and development side, so philosophically also the mathematics people are good thinkers, and they have more I can say the way of thinking, and they are more faster than the others and having the more logical ability. So their visualization is, I think, the far better than others, because even the fixed point theory and applications, we were talking about the approximation theory, best approximation theory, okay, all such things. So definitely this is going to work for us. This is another, when you talk about the processes, these are the processes of the data science. You can see here, this is how to model building is there, then how do you going to operate them, then how you are going to communicate your results, and finally what are the discoveries are. So this is what you can speak about. Then there are some cases also you can see here, and then you need to learn the lot of case study also, and based on the case study, that data visualization is possible, and you can visualize that how the this graph is going on, and what is the future of this graph, means you can extrapolate as well as interpolate also. So these are some discoveries, preparation, and then model planning, etc. Then model building, operation, then communicating the results also. So regarding the jobs and other things, etc., because now these days our government is also talking about that what is out of this mathematics uh, for your students. So they are more concerned about the job prospects also, and they always, most of the interdisciplinary people talking about that we should work with the mathematics, and mathematics people should come forward and they should work with the other people. So I think this is the best time that we can work with the commerce people, some social sciences people, and computer science people, and we can have the very good results. For example, these are some areas that you can find the jobs in while understanding the data science. This is like the data analyst is one position, and you have many other positions once you are go through the data analysis part. The second one is the data scientist also. This is a little bit higher than that, and you have the data engineering part also. So for that, not necessary that you should be computer scientist or computer engineer only. You can be a good mathematical background student, and having these adequate programs, like as I said, R. This is not necessary now. Python is have taken up. This SQL is also fine. That is SQL. Now the MATLAB and other things also not necessary. So Python SQL will do. And then when we talk about the data engineering side, then we have such languages also. Okay, these are all what actually the people they were using earlier. They are more able to make use of the Excels also. So now these days we are not more fascinated towards using the Excel. This Python is enough to understand that. Means overcome from the Excel. Then this is the data analysis, as I said, and then the statisticians. This one, data administrator jobs also there, and business analyst also. This is also the part of this data science. These are the tools for the data science. You can see here this R, Python, MATLAB, Java, SQL, all those things. try to understand what exactly the difference between this business intelligence and data science. These are few points I have given into that, and try to make the difference between the data science and business intelligence. These are some applications of data science, like internet search. Now these days, we are while writing some mails to other, like even the Google is also now AI enabled. So the browser itself is providing you the data, means depending on the vocabulary of the browser. So the AI is providing you the data that you can write this, you can write this. Means based on your own thinking, you can have the vocabulary, and you can write the good script also. Now these days, one of the best example of this is AI is the Chat GPT. And many people feel that it is a threat to the new generation, but I don't think it's a threat, because there are many people. Recently I heard that IIM Ahmedabad, few professors are allowing students to make use of the Chat GPT, but many professors are not allowing to make use of the Chat GPT. Definitely, it is hammering towards the developing their own IQ, but for some people, if they get some sort of the help, then they can do some wonders also. So these are some applicational areas. Few things this is also, that is the gaming world, and online price comparison. Like when you are trying to buy few things, a particular kind and few branded items, then you can have the comparison. This comparison can be done by the using the data science mechanisms. So these are the challenges of the data science now these days. You can see here, that is what exactly the points are given here, like the privacy issue. One of them is, then business decision. That is what. Then explaining the data science to others is difficult. Okay, lack of the significant domain expert. This example can be given in this manner, that, for example, to diagnose for a particular kind of disease, how the data science is going to help is that there are many medicines available in the market, but which medicine is good and which medicine is not good. The effect of the particular kind of medicine is prescribed by a particular doctor can be examined by the using the website, and the information given for that particular kind of drugs. This is what the summary of the data science. Okay. So ultimately, what I can say, that by learning a few things, one can understand what exactly the data science is, because this data science is now the new trend of technology, I can say that, and is generating a lot of money also towards the young generation. Uh, one, I can suggest that apart from your own research, you spend some more time on this, and you can have the good results, because of the mathematics student can give the better and best results when we compare to the other people. This is what I can say, that I think a lot of time already uh, over in this regard. So this is what uh, the about the data science I can say that, uh, because what I observe is in my postgraduate studies is we have the project also, because now we are under the banner of the NEP 2020, and our university, I think, probably is the first university that they have implemented the NEP 2020 full-fledged from the first year onwards. So in that scenario, we have a lot of projects for every student. They have to go through the projects. So this year, I picked 4 students, and all the 4 students did their projects in data science. Earlier, they used to do in fixed point theory, or some of them are in the nonlinear functional analysis, someone in the topology, etc. And I have seen that now these students are more fascinated, more interested, because in the outer world they use lot of computational gadgets, and by using such gadgets they are more I can say that interested towards programming also, if we motivate them properly. And they have presented very well, and they have given the very good insights also. So that way, I felt myself that I should speak on data science, because a lot of mathematics audience is there, and that is the reason that why I have chosen for this 15-20 minutes of my demonstration, data science and all such things. I think. If any question, I'm thankful to the Professor P.D. Srinivas Garu and okay, other people for inviting me. But I'm sorry that I could not attend in person. Thank you.
Many thanks to Professor. Many thanks to Professor Murthy for exposing the utility and the reason why one has to pursue data science today, and
Yes,
a great possibility for many of the current mathematicians, especially youngsters, to take to the multidisciplinary type of research.
Yes, sir.
And this would be extremely useful to the current generation, and
Yes.
the participants are encouraged to email the speaker if they have any doubts or any clarifications or anything else that they want to know regarding data science. Extremely thankful to you, sir. Thank you so much.
Thank you, sir. Thank you. So any question? No questions, sir?
Then we'll come back.
Okay. Thank you, sir. Thank you. I think I can push off from here.
Yes, sir. Yes.
Okay. Okay. Thank you.
So we have to come back by 1:30.
సార్ మీరు అందరూ ఎలా అంటే you have all helped us.
No,
Helping us out.
we have to help us. It's our duty. Let's leave it as our duty.
Sir, please accept our station, sir. This is from UASMS, not from the.
Yes, yes, yes.
This is from UASMS. We are on. Please accept our invitation. Our
Stage by
please.
మళ్ళీ సార్ అన్ని ఎక్కాలంటే కష్టం. ఇక్కడ కూర్చోండి.
UASMS and SMS.
మీ దగ్గర తీసుకోవడం అదృష్టం సార్.
సో మా
Thank you, sir. Thank you very much. Thank you.
This session in the evening session, parallel sessions in the room number 116. Okay, presentation online shall be here and offline shall be in the from. Now we will proceed for lunch. Up to 140, 145. Okay. So let's proceed for lunch and we will resume the next session at 1:45.
ఆయన సార్ ప్రభాకర్ సార్ వస్తున్నారనండి.
ఇండుగా రాసేస్తారు
ఫాస్ట్
చాలా ఫాస్ట్
సీనియర్స్
Good afternoon, everyone. Welcome back. So, those who are online, I think they are able to hear. It's my privilege to introduce our keynote speaker, one of the keynote speakers, Professor G.V. Ravindra Babu. Ravindranath Babu. So, sir needs no introduction because he's here, worked for long years, but for the younger colleagues, we should know what he has contributed to the field of mathematics. So, his research area is fixed point period applications, then approximation of fixed point theory. So he worked as UGC project, but I don't want to spend time on those things. But let me explain his academic contributions. He made vast contributions, about 162 publications in the field of fixed point theory. I just visited Google Scholar, so those who are interested to know, please visit to know the spectrum of journals where he has published. So apart from his vast experience, he held a lot of admin positions, which include head of the department of mathematics and also chairman BOS, and notably he worked at the institute level, that is at university level, chief warden, AU Science College Hostels, and assistant principal, AU College of Science and Technology, dean, PG and professional exams, and towards end he worked as a registrar of Andhra University and retired as a registrar of Andhra University. Also, he held several positions, supervised a number of PhDs. He had a large number of projects, research projects. So, with this brief, it's a privilege for us that he is giving one of the keynote talks. So I request Professor Ravindranath Babu to kindly. Thank you, sir. So, just a gentle reminder, sir, for 45 minutes.
Respected chairman of this session, Professor Rajshekhar, and my mentor in fixed point theory, Professor K.P.R. Shastri Garu, respected professors and respected delegates of this conference, and dear students, research scholars. First, I thank the organizers of this conference, International Conference on Pure Applied and Engineering Mathematical Sciences 2024, for giving me this opportunity to deliver a keynote address in this international conference, prestigious international conference. And it includes all branches of mathematics. And now I wish to deliver my talk on comparison of various contraction type mappings and recent developments in fixed point theory. All of you know here MSc students are there and research scholars are there, and all of you know that a fixed point means if X is any non-empty set and T from X to X is a mapping, then if there is a point X in X, as the Tx is equal to X, then that X is a fixed point of T. Here you have, for example, if you take T from R to R by Tx is equal to X, then each point of R is a R means the set of all real numbers. Each point of X is a fixed point. How many fixed points it has? Infinitely many. In this, if you consider Tx is equal to X square, then how many fixed points it has? It has 2 fixed points, 0 and 1. And now another question, if Tx is equal to X by 2, all T's are from R to R. Okay, how many fixed points it has? That T has unique fixed point. Here the question is, for application purposes, existence of unique fixed point is necessary. So in that context, the fixed point theory developed. For the development of fixed point theory, it is in 2 directions in my opinion. One is on the generalization of conditions on T. Under what conditions T may have unique fixed point? That is the question. And if the development of fixed point theory is under what conditions the map T has a fixed point. Okay. That is in one direction. The other direction is generalization of the ambient space. Here, T from X to X means this capital X is known as the ambient space, and how we can generalize that ambient space. In that general space, can we get the existence of fixed points? In the year 1910, Rover, he obtained one fixed point. That fixed point is, suppose that K is a non-empty, closed, convex, compact subset of R in a finite dimensional space, and if that T is a mapping which is continuous from K to K, then it has a fixed point. Okay, then it has a fixed point. Here, for simplicity, we can consider a map T from closed and bound interval AB to AB. You take closed interval AB to AB, or closed interval, in fact, a more simple case, 0-1 interval to 0-1 interval. If you consider T from 0-1 to 0-1, and if that T is a continuous map, then it has a fixed point. And the fixed points are nothing but the intersection of y is equal to x line and the curve, continuous curve on the compact interval 0-1 interval. So those are the fixed points. Okay. This Robert's fixed point theorem, it gives only the existence of fixed point, but any computation algorithm is there to obtain the fixed point. That is the question. Okay, we have to find out that fixed point through computations. How it has to be. That is invented by Banach. That is in 1922. That is in 1922. In fact, Banach used Picard iterations. In Picard, used those Picard iterations in his differential equations theory in the year 1890. 1890, Picard used Picard iterates for finding solutions. And in 1910, Rover proved existence of fixed points without any computational iterations. And 1922, Banach established a fixed point theorem in complete metric spaces for contraction maps, and he proved that it has a unique fixed point for contraction maps in complete metric spaces. And here the definition of contraction mapping is d of dx dy less than k times dxy for all xy and x, where for some k in open 0-1, and just by viewing it, one can say that mapping is a continuous, uniformly continuous mapping. So contractions forced the map to be continuous. Then the natural question is, what about a map which is not continuous? Then can we find the existence of fixed points? That is the next question. So the question was answered by Kannan in the year 1968. 1922, Banach, 1968, Kannan. And Kannan is Indian, and he is no more now. And he established, or he defined a Kannan map as there exists lambda in 0 that is not t in 0 of. So the d of dx dy less than lambda times d of x dx plus d of y dy for all x, y in x, then he has a unique fixed point in x. That is known as Kannan mapping, and that theorem is known as a Kannan fixed point theorem. Next, similar to the condition, Chatterjee in 1972 established one more theorem in the same direction, but we can take it as a dual one, and d of dx dy less than gamma times d of x dy plus d of y dx for all x, y, and x, where gamma belongs to 0 of, that is known as C contraction, and in complete metric spaces as a unique fixed point. There are now we have 3 fixed point theorems, and in what can we say about the relation between these 3 conditions? That is next question. the roads in 1974, he established that all these three conditions are independent. So, to get the more general contraction condition, Jamferescu in 1974, I think, he established one definition like this. A mapping T XUX is called Jamferescu operator if there exist real numbers alpha, beta, and gamma satisfying 0 less than alpha less than 1, 0 less than beta less than half, and 0 less than gamma less than half, such that for each x, y, and x, at least one of where are contraction holds, Kannan map holds, or Chatterjee map holds. Then we have such mapping is known as Jamferescu map. And in complete metric spaces, Jamferescu map has a unique fixed point. Okay, that is a very interesting theorem. And then Hardy and Rogers, in the year, I think it is 1973, they established one more theorem, d of tx dy less than a times dxy plus b times d of x dx plus b times y of ty, yty plus c times d of x dy plus d of y dx for all x, y, and x with a plus 2b plus 2c less than 1, then p has a unique fixed point in x. Okay, all those three conditions, right hand side terms I added, and he proved that one in complete metric space. It has a unique fixed point. Very interesting result is Sirik's result. In 1974, Sirik established the following result, which says that a map T that satisfies d of tx dy less than or equal to q times maximum dxy, d of x dx, d of y dy, d of x dy, d of y dx for all x, y, and x, then T is said to be a quasi-contraction. What is the importance of this quasi-contraction? One may ask. So, any contraction is a it is a Jamferescu operator. Any Kannan mapping is a Jamferescu operator. Any Chatterjee mapping is a Jamferescu operator. Jamferescu operator is a quasi-contraction. So, all those conditions imply quasi-contraction. And Sirik proved that, in fact, it is proof in complete metric spaces, T is a quasi-contraction and T is it is complete in complete metric space also it holds, then T has a unique fixed point in X. Okay, very interesting theorem. This one is up to this one. Okay, directly we are getting the existence of fixed points. In the new direction, wherein he investigated, can we replace those conditions by like this? D of dxy less than delta times dxy plus L times d of x dy for any xy in x and L greater than or equal to 0. And there exists delta in 0, 1 and L greater than or equal to 0 such that that condition holds. That condition is known as weak contraction. Okay, this condition is known as weak contraction. Examples of weak contraction are, see here, any Kannan mapping is a weak contraction. Any Chatterjee mapping is a weak contraction. Any Jamferescu mapping is a weak contraction. Now, about quasi-contractions, if 0 less than h less than half, up to that one it is a quasi-contraction. But there are maps for which h greater than or equal to half and less than 1, which are satisfy quasi-contraction. Okay, then he asked an open problem such that is every quasi-contraction a weak contraction? That holds or not? He posed an open problem. That problem was solved by myself, Sanjay and Kameswari, and its answer is no. We have given an example. That's all. Okay, and then let us go for the existence of fixed points. Wherein they proved that every weak contraction in a complete metric space has a fixed point. Okay, but it is not unique. The fixed point is not unique. So, in order to get the uniqueness of fixed point, wherein they use another definition on T, And that is, if there exists delta belonging to 0, 1, and there exists L1 greater than 0, such that d of tx dy less than equal to delta times xy plus L1 times d of x tx. That is another definition. And here the wonderful thing is that weak contractions and this we can call this one as condition A. Condition A, both are independent, which means that weak contraction holds, but this condition A fails to hold, and condition A holds, but weak contraction fail to hold, and hence these both are independent. So he, by using this additional condition, he found the existence of unique fixed. Existence means existence for existence one condition, and for uniqueness another condition. So he has to use two conditions. Then he posed one more problem. Can we get the existence and uniqueness for a single contraction condition? That is the question. For a single condition, can we get both existence and uniqueness? That question was also answered by myself, Sanjay, and Kameswari. And here we used the condition that d of tx ty less than or equal to delta times dxy plus L times minimum of d of x ty, d of y tx. That's all. So by using that condition, we obtained existence and uniqueness for with a single condition. And here I wish to say that our condition is known as condition B, and condition B implies weak contraction. Condition B implies condition A. So our condition is a little bit stronger, but it gives us the existence and the uniqueness both. So like that, the theory was developed. Condition B means d of x tx, d of y ty also, it is included here. Not at all, but those two also included. Okay. So if x is a complete metric space and if P satisfies condition B, and then P has a unique fixed point in X. And the other direction of development of fixed point theory is by altering distances. Hans, Waller, and Sessa considered a function phi from r plus to r plus means 0, infinity, closure 0, open infinity, satisfying the conditions. Phi is continuous, phi is monotonically increasing, and phi t is equal to 0 if and only if t is equal to 0. By using that condition, they established existence of fixed points. Very excellent results. They were proved in the year 1984. And that one, next day. Transfer and Sessa proved that a variant of the term is let x be a complete metric space phi belong to phi t x to x, which satisfies phi of d of tx dy less than c times phi of dx for all x y in x, and for some 0 less than c less than 1, then E has a unique fixed point in x. In fact, here I would like to say one thing. Hans, Waller, and Sessa in 1984, they developed, and after that they initiated, and after that, say Park and some other mathematicians, they established some fixed point theorems, but they used subadditivity property of phi. If phi is subadditive, then there phi circle d, phi of d is again a metric. So there is no importance of such phi. What we did is, myself and Professor KPR Sastry garu, we established fixed point theorems without using the subadditivity property of phi, and this technique became famous with our paper that is published in Indian Journal of Pure and Applied Mathematics in the year 1998. Now, on the way of generalizations, Albert and Delabriere, they established a generalization for contraction mapping principle for contraction mapping in the setting of Hilbert spaces. But Rhodes extended to metric spaces, and that is d of dx dy less than or equal to d of xy minus phi of d of xy for all xy in x, where phi belongs to phi is an alternate distance function. Here we know that such function t is called weakly contracted. Here we know that every contraction map is a weakly contractive map, but its converse is not true, so that weakly contractive maps are more general than the contraction maps. This is the other direction of doing generalization of contractions. Okay, so in a complete metric space, every weakly contractive map has a unique fixed point. That is proved by Rhodes. Now, that one is generalized by Datta and Chaudhary. They both are from West Bengal. And they proved that if there exist two alternate distance functions psi and phi, such that psi of d of dx dy less than psi of dx minus phi of dx for all x, phi, and x, then t has a unique fixed point in x. Here, please note that phi and psi both are continuous functions. If we take psi t is equal to identity, psi t is equal to t, then we get a weakly contractive map. So that theorem follows as a corollary. And here that psi is identity, then it is a corollary, then we get the corollary of Rhodes theorem, and on right hand side phi is also continuous. Next. In the generalization of contraction conditions, one more thing. Right hand side contraction, in place of the contraction, right hand side c times dx by can be replaced with rational terms. Here, Das and Gupta, they used d of dx by less than alpha times d of y dy plus into 1 plus d of x dx by 1 plus dxy plus beta times dxy for all x, y, and x, then t is said with Das and Gupta contraction. In a complete metric space, if that map T is continuous and satisfies Das and Gupta contraction, then it has a unique fixed point. And in the year 1977, Jaggi, another mathematician, he proved that d of dx dy less than alpha times d of x dx and d of y dy by d of xy plus beta times d of x for all x, y, and x, if that's different from y, then we call that map a Jaggi contraction. In a complete metric space, if T satisfies Jaggi contraction and if T is continuous, then it has a unique fixed point. These are the existence of fixed points. Next. Next. After this one, we studied or we discussed only on the case of generalization of contraction conditions. Now, what can we say about I wish to give a flavor of the generalization of ambient space also. So, in the case of generalization of ambient spaces, Wataru Takahashi, he established convex metric spaces. He defined in the year 1970. XD metric space Wx cross 0, 1, 2 x be a map for all x, y, and x, and for any lambda in 0, 1, d of u w x y lambda is less than lambda times dux plus 1 lambda times uy. For any u in x, then we see the w is a convex structure on x. Okay, so a map would a space x together with the w, that is convex structure comma d, that is known as x metric space. So, what is then? Is there any example for such a convex metric space? Means here you have. It is easy to see that every normal linear space is a convex metric space. But there are convex metric spaces which cannot be embedded in any normal linear space, so that convex metric spaces are more general than normal linear spaces. So we have next. That is here we take the convex structure w x y lambda equal to lambda x plus 1 minus lambda y. If we consider that one, it is a for any x, y, and x and lambda in 0, 1. Then it is easy to see that it satisfies convex structure, but it cannot be embedded in any planar space. An example is provided here: 0, 1 infinity cross 0 infinity set and metric defined, but it is not a linear space because there is no 0, 0 in that space. Next. Yeah, and the following properties of convex metric space, d of convex metric d of x, w x y lambda equal to 1 minus lambda dxy, and d of w x y lambda y equal to lambda dxy, d of x y equal to d of x, w x y lambda, d of w x y lambda y. Okay. And user proved a fixed point theorem for self maps like this in a convex metric space. FP self map and C if 2p times mod C less than the k tile less than 2 into a plus b plus c minus mod C. There are certain sufficient conditions used and established the existence of fixed point. And Chang and Wang also used some type of condition. This a times dx by this is okay. In the previous case, a plus 2b plus 2c less than 1, then it has a unique fixed point. But here, the sufficient conditions they changed, and here you have more flexibility is there. And with that condition, we call it the general non-expensive map. And he proved in a convex metric space the existence of fixed point, and if a plus 2c less than 1, then t has a unique fixed point. This is the earliest work. Now, the recent work, how the generalizations are made. Enriched non-expensive maps, enriched contraction maps, and comparison of various contraction maps. The non-expensive, all of us know that next. Norm tx minus t by less than norm expensive for all x, y, and k. Next. Quasi non-expensive. Here, quasi means the norm of tx minus t by less than or equal to norm of x minus q for all x and k and for all q in fixed point of t. Here you need not, that inequality need not hold for all x, y in x. For all x in x and for all q in fixed point of t. Here we have to assume that fixed point of t is non-empty. And within there, he defined that x norm be a non-linear space at tx to x. If there exists a b in 0 plus infinity such that norm of p of x minus y plus norm of tx minus norm of tx minus t by less than p plus 1 times norm x minus y for all x, y, and x, then t is an enriched non-expensive mapping. Here we use b, so sometimes we call it as b enriched non-expensive map. Now the question is why it is called an enriched non-expensive map. That is the question. If b is equal to 0, then we get just a non-expensive map here. So for the case b is equal to 0, it is non-expensive, though it is enriched. And in that sense, it has, and a 0 enriched non-expensive map is non-expensive map. So similar to the case of even a non-expensive map is a continuous map. Similar to the case of non-expensive maps for enriched non-expensive maps also, it is a continuous, and even the enriched non-expensive map is also continuous. It is very easy to verify. Very simple. So the richness of new class of enriched non-expensive maps was illustrated in the following example. See, let us see the example. Xb equal to half 2. We endowed with the usual norm Tx to x, we defined by Tx equal to 1 by x for all x in half 2. Then T is a 3 by 2 enriched non-expensive mapping. Fixed point of T is equal to c and 1. But T is not quasi non-expensive. Okay, understand it? T is not quasi non-expensive. Quasi non-expensive map need not imply B enriched non-expensive. Here is an example we have. Here is an example we have. If x equal to 0, if x equal to 0, x and 1 by x, if x different from 0, then f is quasi non-expensive, but it is not next. If it is, but it is not. It is f is not b enriched non-expensive, so it is not non-expensive. So f is neither non-expensive nor b enriched non-expensive. So that the B enriched non-expensive maps and quasi non-expensive maps both are independent. Now, wherein they prove this theorem for demi-compactness, they use some definition in order to approximate fixed points of enriched non-expensive mappings. Wherein they use the Tarski iteration and prove the following strong convergence theorem. Next. he proved that cross-Nusselt's iteration xn plus 1 is equal to 1 minus lambda x plus lambda tx and n will converge spanning to a fixed point of t. Next. Wherein the 2020, wherein the figure introduced a large class of contractor mappings called enriched contractions has a particular case and also certain non-extensive ones. Here we have, up to now we studied enriched non-expansive mappings. After that, he defined enriched contraction maps. Now, in a nonlinear space, Tx to x self map, if there exists the b in 0 infinity and theta in 0 b plus 1 such that the norm of p of x minus a plus bx minus t by less than theta times norm x minus y for all x minus x, then we say that it is an enriched contraction map. Here, why it is known as enriched means if b is equal to 0, then it is just a contraction. So 0 enriched contraction maps are contraction maps. So in the case, these are all enriched contraction maps. And within there, and people are given an example, let 0, 1 be endowed with the usual norm tx equal 1 minus x. Then, so that t is a b theta enriched contraction, but it is not a contraction. Every enriched contraction need not be a contraction, and hence enriched contraction maps generalize contraction maps. So it is non-expensive. Next. Enriched contraction 20 is equivalent to this one. For any b in 0, 1, t is a b, 1 minus b enriched contraction. In this case, fixed point of t is off. Now the following question is possible. Is every non-expansive map a b theta enriched contraction map? That is a question. And we answer that one. Let x be equal to 0, 1 with the usual norm, dx is equal to x identity map. Then these are non-expansive. So it is not a b theta enriched contraction map. So non-expansive maps are not enriched contraction maps. Next. And for b theta enriched contraction, he proved one theorem that that Krasnov-Sliski iteration that converges to the fixed point. Next. Next. Let now enriched contraction maps defined like that. Enriched Kalman maps also be defined like this: k times x minus a plus cx minus b by less than b times x minus cx is y times y minus b by. Then it is known as kb enriched Kalman mapping. If k is equal to 0, then p is a Kalman mapping. And he proved that in a Banach space, enriched Kalman mappings. If p is an enriched Kalman mapping, then the Krasnov-Sliski iteration converges to the unique fixed point. Next. Like this, for Chatterjee, enriched Chatterjee map also we defined. Next. KAB enriched Kalman. Next, KAB enriched CRR map. Here, norm of k times x minus y plus norm tx minus t by less than a times norm x minus y plus b times norm x minus 6 is norm y minus t by. Then p is a KAB enriched CRR map. If k is equal to 0, then p is a Siric Reach CRR contraction. If b is equal to 0, then p is a KA enriched contraction. KA enriched contraction. If a is equal to 0, then p is a KB enriched Kalman mapping. And KAB enriched contraction map, if T is a KAB enriched contraction map, and if the iterations are defined by Krasnov-Sliski iteration, then they converge to a unique fixed point for such maps. And these are fundamental properties of convex metric spaces. And here one interesting theorem or lemma that XW be a convex metric space, T x to x be a self map, that lambda belongs to 0, 1. If we define the map T lambda from x to x by T lambda x will W x dx lambda of x belongs to x. Then for any lambda in 0, fixed point of T is equal to fixed point of T lambda. So for any lambda, we have fixed point of T equal to fixed point of T lambda. And within they defined lambda c enriched contraction d of w x dx lambda d of y t y lambda less than c times dxy for all x y in x 0 less than equal to c less than 1. Here next. Okay. Here if we write for each lambda t lambda from x to x, then what happens? T lambda from x to x, then the enriched lambda c contraction, the definition takes the form b of t lambda x t lambda y less than or equal to C times dxy for all x, y, and x, so that it is a contraction. But here, what is the greatness here? It is just a contraction. In complete metric space, it has a unique fixed point. But why it is known as enriched contraction? Here, E lambda, in a normal linear space, every B theta enriched contraction is a lambda C enriched contraction. The lambda equal 1 by B plus 1, C is equal to lambda theta. And hence, it is enriched contraction. They called a map of T that satisfies D of Wxy x dx W of D of x W of x dx lambda W of y t by lambda less than C times dx that is called enriched lambda C contraction. That's the reason. And here we have an example for which it is lambda C enriched contraction. Next. And one more example is given we have, that is T is not a lambda C enriched contraction. And here the existence of fixed points xn plus 1 equal w, xn, px, and lambda, n equal to 0, 1 to so on, converges to T, say in x, and P is a unique fixed point. Okay, next. Like that, AB enriched CRR contraction we defined, and it has a unique fixed point. Next. And in many places, we use this lemma. If it is not Cauchy, xn is not Cauchy, then there exists epsilon positive and CP is a positive integers mk nk with mk greater than nk greater than k such that v of xmk greater than epsilon, v of xmk minus 1 xmk less than epsilon, and limits all those identities hold. Now, enriched psi-phi lambda weakly contact maps. This is defined by us. This is latest work that we developed. Okay. And the weakly contraction map, enriched weakly contraction map, we define it as psi of d of w x px lambda w y t y lambda less than the psi of d of xy minus phi lambda d of xy. Phi lambda increasing and phi lambda t is equal to 0 if and only if t is equal to 0, then t is an enriched psi-phi lambda weakly contraction map on the convex metric space X. And we have given one example here. Phi lambda t is equal to 3t, t greater than equal to 0, and psi t is equal to t for computational purposes. To avoid cumbersome computations, psi t is equal to t we have taken, and we have given an example. And one here, xw be a complete convex metric space. Suppose that t x to x is an enriched psi-phi lambda weakly contact map, then t has a unique fixed point next. Here one may ask, what is the purpose of studying this theorem? Already Chaudhary and Datta, they did it in metric spaces. But when they are giving the proof, then both the maps psi and phi are continuous. But whereas here we did not use any continuity property of phi in the proof. That is the greatness of this theorem. These are properties. And this is an example in support of our theorem. Okay. Now, fixed point theorems in convex metric spaces. Here, almost contractions within the, and we solved an open problem by the motivation, by taking the motivation of that one, we defined almost contraction maps like this, and definition like this, almost generalized non-expansive type map. And here ABC are not necessarily non-negative. If L is equal to 0, then T is a generalized non-expansive map. And for such maps, it has a fixed point in complete convex metric spaces. If A plus 2C less than 1, then T has a unique fixed point next. Here, all these are existence of fixed points for almost contraction type maps with the different types of contraction maps. Next. These are examples. Next. Go ahead. All are different types of contraction maps. We did it. Next. Next. Here, Jaggi contraction and Das and Gupta contractions we studied, we discussed, and enriched Jaggi contraction and enriched Das and Gupta contractions we developed, and those are these are Jaggi contractions. Okay. K times x minus y plus Tx minus Dy less than alpha times lambda x minus y plus beta times this one. And here it is a, what is this one? Das and Gupta contraction, Jaggi contraction, enriched Jaggi contraction. If k is equal to 0 here, we get Jaggi contraction. So it is an enriched one. Therefore, it gained an importance, and we have shown that enriched contraction map condition holds, but whereas Jaggi contraction condition fails to hold, and hence this is a generalization. In the same way, we extend it for Das and Gupta contractions, same ditto generalization, and we prove the existence and uniqueness of fixed points. Next. Okay, up to this one, it's good. Okay, by defining it. 5 minutes. Fine. So, and we extend it for a pair of maps. Next. One minute. Here, convergence of sequence of fixed points of enriched contraction maps. Here we have. Let's TN be a sequence of K enriched contraction maps defined on a paraxis U, and we have it has a unique UNs of fixed points of TN which exists by the earlier theorem. If TN converges uniformly to T, then UN converges to U implies that U is a fixed point. Conversely, if U is a fixed point of T, then UN converges to U provide K less than 1 minus. So, very interesting results these are all. Suppose that Tn has a fixed sequence of fixed points, and that Tn tends to T uniformly, and Un tends to U uniform. Un tends to U. Then what can you say about the relation U, and what is the relation between U and F? Such theorems we provide. Conversely, if U is a fixed point of T, then Un converges to U or not. That is also we established on this part also. These theorems we established for enriched Jaggi contraction maps, enriched Das and Gupta contraction maps. This is the latest one. And next, an open problem. I want to not open problem. It is suggestion to do further research. That is, for future research, some new fixed point results can be investigated by defining generalized enriched contractions by multivalued enriched contractions. Not yet done anyone multivalued enriched contractions. So, those who are interested, they can pursue this problem. And these are the references I used. Now, here, the main content of this talk is taken from the following research papers: GVR Babu, C.H. Srinivasan, and P. Monica. A fixed point theorem and enriched sci-fi lambda weekly contractor maps in convex metric spaces. Journal of Ramanjan Mathematical Society of Mathematics and Mathematical Sciences, 10/1/22. And GVR Babu, P. Monica, fixed points of enriched contractions and almost enriched CRR contraction maps, rational expressions and convergence of fixed points. Proceedings of International Mathematical Sciences, 5/1/2020. And the other one is GVR Babu, C.H. Srinivasan, and B. Monica, fixed points of certain enriched contraction maps in convex metric spaces. Advances in applications of applied mathematical sciences. This is accepted for publication. These are the from these three papers I prepared this notes. If you have any doubts or any questions, please ask me.
The first has given a summary of the proceedings on fixed point theory and its developments, in particular on enriched
contraction maps.
Okay, and also he talked about Berinde recontractions. Okay, so it tells how the theory developed and then what are the open problems, the big ways which are solved, and the field is very vast, and he has nicely narrated the development and then given some hints on application areas. And but then he has given an open problem. So those who are having clarifications or doubts, etc. So you can talk to him, feedback, etc. So we take this opportunity to thank the professor. Thank you. Thank you for giving me this opportunity.
Small presentation.
Sir, join us.
Thank you. Okay.
Sir,
Okay.
you have chaired our session.
Thanks.
Sir,
Sorry. Leave it. So it is talking
Next invited talk by Professor Professor G.P. Rajshekhar garu, and chair the session by Professor N.V.E.S. Murthy garu. Now I invite N.V.S. Murthy garu, please chair the session.
Good afternoon, everyone. I'm extremely pleased to introduce the speaker, Professor G.P. Rajshekhar. He is actually far junior to me in Central University of Hyderabad. Okay. And also another junior I have here, P. Anuradha Kameswari. Okay. To say a few words about him, actually he is a very meritorious person, to be frank, Rajshekhar. Okay. To make it very brief, okay, I'm personally pleased with his performance. Okay. Of all my juniors, he is one of the most well-known person. Okay. He is an Alexander von Humboldt Fellow of, and then he is a research visit He visited Oxford University and also University of Bremen. Okay, I didn't know that you visited University of Bremen. Austerlich was there. Okay, he was my
That's fine.
doctoral committee member. Austerlich.
Fine, sir.
Next one,
I mean,
he also visited Romania, Cambridge, and then Oxford University, and he also visited University of Birmingham, blah, blah, blah. Okay. He was also a postdoctoral fellow in Tokyo University. Okay. With these few words, I'll give him a.
Thank you very much, sir. Professor Muthiar for his kind introduction. Even though I was feeling embarrassed to, because these days, if you are interested about a person, you can know from the internet. So thank you very much, sir. Actually, this is deliberate, even though my other friends may not like me speaking about fixed point theory, but it's a deliberate. Yeah. So it's a bit deliberate that because many stalwarts are here, so I thought let me also just make an attempt. But it's coincidental. We have done the work. It's not that for this conference I have done it. So I work in PD theory and applications, right? So this is one attempt. Okay. So thanks to the organizers and our good friend Professor Srinivas Rao, and then my batchmate at PhD, Professor Anurada Kameshwari. So modeling and analysis of nonlinear equations in porous media. I work in flow through porous media. Okay. So I should be. Okay. So this is. So even though my predecessors talked about, sorry sir, I will use the mouse. So even though my predecessors talked about fixed point theory, how do I go back? I cannot go. Can you go back? Go back. Back. Yeah. So yes. So I'll talk about briefly about a review on a different perspective, even though about fixed point theory. So then a couple of nonlinear PDEs and how we show existence uniqueness using fixed point theory. Okay. Yeah. So this I'm skipping for the sake of so the definition, etc. I'm skipping. So now let me take a nonlinear ordinary differential equation. So you have on the right hand side y and multiplying with any function of y. So it's nonlinear, right? So what we do here, we are linearizing it. So you take f of y, call it u for the time being, which I assume that it's a priori known to me. So then it is linear. So one can solve 2.2 because u is known for the time being. So one can solve 2.2 and then you get an equation that is the solution of 2.2. But what we do, you rewrite equation 2.3 as y equal to g of f of y x. So now this is a map which defines an iterative scheme. So the moment you get the converging solution of this iterative map, you have the solution of the nonlinear equation. So that means essentially you find the fixed point of this. So then you get the solution of the nonlinear equation. I think it doesn't work. Please do it. Okay, next. So you have nonlinear function on the right hand side, sin y. So you assume that sin y is known as u. So then do this iteration. So you can see direct Euler method versus the fixed point iteration method. Of course, Euler method is very crude. That's why it's not. So rather here, fixed point iteration method is better solution. Euler method is first order. So it's giving underperformance. Next. Yeah. So it's a simple y square. So the nonlinearity is lesser. Sin y is higher nonlinear. Here it is just so therefore Euler method is doing much better. Okay. So what is the summary here? Summary here is if you have a nonlinear equation, you linearize it and define a map and find fixed point of that. Through that you can get the solution of the nonlinear. So the definitions are given. So I am skipping all previous speakers have given. So I'm skipping. So now let us take this another example. So this is an integral equation. So your unknown is the F. It's a Fredholm second kind because the unknown is outside, not only inside the integrand, unknown is outside. So it's a Fredholm second kind. So now under these assumptions, you can define a map from CAB to CAB, set of all continuous functions AB. So this is a map now, okay? So please, yeah. So now you can, under these assumptions, you can work out all the steps, estimate the function, then come up to Banach contraction, right? So once you have this, you need a contraction, right? So for the contraction to exist, you need the estimate on modulus of lambda. So if modulus of lambda satisfies this, so then you have fixed point and the iteration converges, so you have uniqueness as well. Okay, so that's the Banach contraction. So variation of fixed points already several speakers have talked. So I'm skipping the definition. Okay, so this is please go back. So one version I want to shorter fixed point. So we are going for the compactness. So you take a subset of X, which is compact and convex, and then T A to A is continuous, then you have a fixed point. Okay. So there are several variations. So this is one. Okay. So now what we do with these fixed points? So the idea is simple. Idea is you have a nonlinear PDE. What engineers does? Suppose you have to find out heat transfer in this room. You have a lot of nonlinearities. For example, how many air conditions are there? So 3 plus 2 or 5. Why 5? Why not 10 air conditions? So maybe they'll say, what is your hall? You need 1.5 ton air conditioning. So that means there is some estimate done. So now when the engineers does it, you see the corners there. So they are taking the PDE model. They are developing finite element solution. And what is a finite element solution? It is not smooth solution. And not only that, suppose your operator is second order. Finite element solution is not second order differentiable. It is one order less because it's called weak solution. Why? Finite element solution is not exists in differential sense, rather it exists as an integral sense. Because we take the operator, we do the multiply with the test function, so then integrate by parts so that the derivatives on the unknown are shifted to the test function. Then you get a reduced order equation, which is called the weak formulation. So then you discretize using a Galerkin method, etc. So that is the finite element method. But then you are losing the regularity. What is regularity? My operator is second order, but your solution is only first order differentiable. Why? Because you don't have smooth life always. So you have a lot of nonlinearities. So there is an issue of the differentiability at the corners. So engineering perspective, you cannot afford for smooth solutions, right? So while engineers develop finite element solutions, as mathematician, we have to show before you do the engineering solution whether the solution exists, if it exists, unique or not, right? So for that, we are going to use fixed point theorem. So for the first few minutes, the operator is same, but the domains are different. So you take this operator, which is the partial differential equation, in terms of two independent variables, velocity and pressure. So what is, it is nothing but simple balance of momentum. That means it's a force balance, right? So here you have U, first term is Laplacian U, which is called a viscous effect. That means you have fluid layers, so people are interacting, so that is the viscous effect, right? If there is nobody, you won't have any interaction, so that is the first term. Second term is, suppose nobody is there, air is very smooth, but people are sitting, so the flow is resistive. So K is the permeability. Permeability means the ease with which we can penetrate. So that is K. So that is the damping term for the flow in the porous media. Second term is its nonlinear term. So that's the one today we are going to discuss. So now you may ask, under what conditions you have a nonlinear? Obviously, the order of the velocity should be slightly larger. So otherwise, flow through porous media, you do not have. Suppose when people are sitting and then you open these windows and there is a use wind, then it will come through. So that will be little nonlinear. So third term, B is the body force and the last term grad P is the pressure force. So it's a typical balance of linear momentum. The flow is incompressible, so therefore you have divergence of U is 0 and we are taking Dirichlet condition on the boundary. So for the time being, you assume that it need not be sphere or circle, it can be any arbitrary domain. Okay. So we are interested in solving this. Before solving, we are interested in discussing existence, but using some fixed point. Yeah. So we do non-dimensionalization. So why to do non-dimensionalization? So today somebody does an experiment of say heat flow in this room, and they say results should be, my results are correct because the dimensions of this room is like this. Somebody does experiments in another room whose aspect ratios are same. The room is much bigger, but the aspect ratio remains the same. So then that fellow also will get the same results. So then they quarrel, right? So what do you mean? Both are correct indeed. Why? Because the aspect ratio remains the same. That means there is some dimension less quantity which is same. That is why both are getting the same result. So we do non-dimensionalization. Yeah. So now this is our non-dimensionalized. So RE is the Reynolds number, which tells how much speed is the flow. Okay, whether you're talking about low speed or high speed. The RC number is the permeability. Okay, suppose you cramp with so many people, so then permeability will be less, right? So more spacious, permeability is more, right? So that is the Darcy number. So now it's a nonlinear setting. Okay, next. So now in order to develop this weak formulation, so remember I gave the definition of weak formulation. You have append with a test function. That means this fellow is bad. To reduce the badness of this fellow, what you do? You say, please, you take care of this fellow. Some friend you give it. So that friend is the test function. Okay. So to develop that, you require these spaces which are not smooth. Okay. So you see the norm in H1D, that is the holder space, right? Which is the solo space which we are defining. So then the corresponding norm is defined and we have divergence V0. That means the incompressibility condition is already hidden into the space. Okay. Next. Yeah. So now you consider U and P are our unknowns. You consider test function V and Q, which are these nice fellows. You append them and I have already done the integration by parts. Right? You can see earlier operator, what is the order of operator on U? Laplacian, right? Second order. But now, only first order. What happened to the derivative? That is shifted to the test function. Actually, I should have had so the test function, right? Everywhere, wherever derivative, we have shifted to the test function. Now, what is the claim? The differential operator is equivalent to this integral operator. Okay. When for all test functions v comma q in this space, but then it's reduced now. That is why this formulation is called weak formulation. It's not the strong classical formulation. It's a weak formulation. Okay, right? So now we want to discuss before you do. So if you give it to engineer, what they do? You go for a Galerkin approximation, then integral is discretized, use some numerical scheme and solve. But before doing that, we want to discuss whether solution exists or not. Okay. So this step is not required. Next. Yeah. So now you look at the first line. What is the nonlinear term? U mod U is the nonlinear term. and we are linearizing. That means for the time being, we are assuming the nonlinear part because mod u is u1 square plus u2 square plus u3 square. That's the nonlinear term. We are assuming it's known. So that's the w for the time being. Now this formulation is linear. So you define the corresponding bilinear form AUV. So it's a bilinear form. Okay. So then you define the corresponding linear functional F. Okay. So this particular weak formulation, we are putting it in terms of an abstract formulation in terms of an operator. And what is the idea? Idea is once I have an operator setting, I can check all the hypotheses of various fixed point theorem and then say that under this hypothesis I have a fixed point. So then proceed further, right? So hope you are getting, I have developed a weak formulation. Then we are developing corresponding to that weak formulation an abstract formulation. So what is A of UV? It's a bilinear form. You can check. It's a bilinear form. And F of V is a linear form. Okay, next. So now what happened? The weak formulation developed is now reduced into a abstract formulation where AW is from this space to this space. Okay, right? But what you want now? So the map is W is we have assumed, but what is our final end goal? End goal should be W should be U. When W is U, we have solved the nonlinear problem, right? Right now I have assumed U as W, which is given, but finally when do you solve the nonlinear problem? When W is U. So for that you define this map which takes, T is the map that we are defining, which takes each W to a solution U by this. Okay. So now, when do you solve this problem? Nonlinear problem for this map if you have a fixed point. Why? If for this map, if you have a fixed point, what will happen? U equal to T of U. Right? So you want to check the conditions under which this map has a fixed point, right? So next. So in this abstract setting, you have to exercise a bit which fixed point theorem you should use, right? It varies from problem to problem. So here what we are checking, you see, first hypothesis I am checking the bilinear form is continuous. The first one. Second one, AW is coercive. The bilinear form is coercive. What do you mean by coercive? I'll show you. The first one is continuity. Which is the first one? The estimate of mod AW is given in terms of various norms. So you got finally a bound for that. So that tells that AW is, this bilinear form is continuous. Coercivity is, see, continuity we are getting it by getting an upper bound. Coercivity, you are showing a lower bound. So that is second step is the coercivity. That means AW is greater than or equal to alpha by RE norm square. Coercivity is done. So then the linear function is continuous. Why I should check this? I could have checked something else. Simple. This setting is allowing me to use Lax-Milgram theorem. So what is Lax-Milgram theorem? If you have a linear map such that it is continuous, coercive, and linear functional is continuous, so then you have a fixed point, right? So that is the reason we are checking this hypothesis. So under Lax-Milgram lemma, you get a unique solution for U equal to TW, which satisfies this estimate. So that means it's not free of cost. So this solution, you're getting it, but you have a constraint. So what is the constraint? So that depends on a lot of parameters. So here comes the mathematician. Why? Suppose as an engineer, you have taken this and then discretized and developed the solution. And you will give it to some software industry, they'll start using it. Somebody will buy, start using it in real life. But who would ensure that these parameters are obliged? No. We don't know. So you are using for all parameters, but the theory says that no, you do not have solutions unless your parameters are constrained. So that's where the mathematician is coming next. So finally, what you are getting, if this is a T, it is a strict contraction, and you have the corresponding smallness condition to apply the Banach contraction. Right. So you have a nonlinear operator. So then you linearize it, define a map, and show the hypothesis of Lax-Milgram, and say that you have a fixed point. The moment you have a fixed point, you are solving the nonlinear problem. Okay. So this is one application of fixed point theorem, and that equation that I have taken is called Brinkman-Forshammer equation, which comes from flow through porous media, tissues, etc. Okay. So I'll keep the same operator, but now, so this whatever we have shown right now is for any D, like 2 or 3, right? Next, same operator, we reduce it in a component form and see what type of fixed point we can use. Okay. So what I'm taking, so it's an endothelial glycocalyx layer. So that means blood is flowing through arteries. Artery middle portion is lumen. Upper, it's a symmetric, more or less. So you can take a symmetry. Upper portion will be consists of some layers of tissue called glycocalyx layer. So above it there is something called lumina. So these are all porous. So when you become very prone to immunity, so there will be leaky cells through that, and then you get loss of immunity. So that is the middle portion. So high shear flow is flowing in the middle, that is percolating to the tissue. That is endothelial glycocalyx layer. So we would like to model. Okay. So that is the induced shear. High shear flow is applied on the edge of this porous tissue. See, this porous tissue is not like a very packed tissue. So there are a lot of fibers. They are arranged in a nonlinear way, anisotropic. Here, the permeability is not isotropic. It is anisotropic, means direction dependent. So you have an anisotropic porous media, high shear velocity is there, and the bottom you have not a no slip. So there is some roughness. Okay. Yeah. So the equation remains the same, but what is the change here? Permeability is direction dependent. It's a 2D problem. So K1 and K2 are the permeabilities along each direction. Phi is the angle of the fibers. Suppose you take a tree. So some trees you see round circles. So how do you cut them? You won't cut them like this. You try to peel it because the permeability is more in vertical direction. Horizontal direction, one layer, another layer. So you try to cut. So permeability and fibers are, see, you see the any woven fibers, there will be some angle for the fibers. So that is the angle. Okay. Next. So next. So in component form, I have written the same equation. 5 minutes. Huh? Yeah, I will be finishing. So I have written the same model in component form, but this time I am assuming simple unidirectional flow so that our model is reduced. So this is just another application of fixed point theorem. Okay. So now I can solve. See the component form. These are the equations. So the unknown is u, which is the velocity. That is the unknown, which depends on the vertical direction, and permeabilities along each of the directions. I assume that it depends on the tissue. Suppose you have artery in this location, some tissue permeability, artery in some other tissue permeability. All those things you should know. Okay, next. So you see the first equation, again it is nonlinear, even though it is a 1D, it's nonlinear. Why it is nonlinear? You see that u mod u. Okay, So now, please, again the same story, but this time it's not a vector test function, a scalar test function. We multiply phi. Phi is the test function coming from the Sobolev space H, H101. Okay. Then you multiply that with the test function and reduce the order of the equation. So this is a weak formulation story. Those who are experts in weak formulation, they will be able to know, right? So I'm not telling the other technicalities of the boundary conditions. How do you handle? Yeah, next. So this is our weak form. Okay. Next. Now, here we are not going for lax milligram. Okay. So here you define the linear functional and the semi-linear form because you are not getting bilinear form. That's why we are not going for lax milligram. So you go for the semi-linear form beta on H0 to H0, that big expression, and the linear functional which is on the right hand side, and you get an abstract formulation. So the story is always same. What is that? Higher order operator is given. You multiply a test function, integrate on a closed boundary so that you reduce the order of the dependent variable. You shift it to the test function. So then you get a reduced order equation, which is called the weak formulation. Then somehow you put this in an abstract formulation using a semi-linear form or a bilinear form, and right hand side a linear functional. So at this stage now we have this abstract formulation, that is beta you had phi is L phi of for every test function. That means what you are telling, this bad person always needs some good person to reduce that. Okay. So whoever is that good person, this is valid, right? So now this, what we show, this abstract formulation has a unique solution where not in any C2 space. Original equation C2, smooth two-dimensional differentiability. No, not there. Reduced form. Okay. So then this is a boundary linear operator. Yeah. For that, you again you check the hypothesis of some other fixed point theorem because lax milligram does not hold, right? So what we are doing, so this again you reduce further. Okay, we have defined A from H0 to H. So you have got a very abstract form in operator form. So then you show this continuity. Next, please. Then beta is elliptic and A is coercive. Okay. So this you show. Then our fixed point experts can easily guess what theorem we are going to use. Yeah, next. What theorem we are going to use. So this is what the final result. Okay. Continuity I am showing. Yeah, please. So Broder-Minty theorem. Professor Ravindra Babu has in his talk he mentioned this theorem. So using Broder-Minty theorem, you say if you have a reflexive Banach space, then if it is bounded, continuous, strongly monotone, that hypothesis, whatever we checked just now, it is to show that it is strongly monotone. So then you have a fixed point. So once you have a fixed point, you have solved the nonlinear problem. Okay. Right? Yeah. So what we have done, I'll skip this. Skip this, please. Next. Yeah. This please go back. Go back. Yeah. So since we have done fixed point iteration method, you recall the example of ODE. Same thing we have tried. You have U mod U is the nonlinear part. You switch to P, something known. So then define the iteration. So numerically, I have shown. Okay. So I have a map Uy equal to G of U. So then I compute until desired accuracy. So then you declare that that is my fixed point. So then this fixed point method requires convergence. What is the condition for algebraic and transcendental equations? To use fixed point iteration method, you require a condition, no? Modulus should be less than 1, the derivative of the modulus. Yeah, that's what we have tested. The derivative of the modulus is bounded by 1. So therefore, the numerical approach also gives pretty accurate results. Yeah, please. Next. I want to show the last slide. Yeah, please go on. Yeah. So approximate solution, that is using this fixed point iteration. Numerical solution, straight numerical discretization, that is numerical solution. Then there is a small parameter using that perturbation solution. So the red ones is for low Darcy number, that is for high Darcy. Intermediate Darcy solution is not accessible because it's a perturbation solution. And the blue one is a full numerical simulation, and the dotted one is approximate solution using the fixed point iteration method. So we have a pretty good convergence. Yeah, please. Next. So these are my PhD students. So part of the work is published in Communications on Pure and Applied Analysis. So those are interested, this American Institute of Mathematical Sciences publication. So those are interested, you can refer. Okay. So this is our first of approach using 6.32 PD. So any questions? Yeah.
I'm sure many of us will have a lot of questions, but we can take time and ask him that.
Thank you, sir.
Thank you very much.
Thanks a lot. Some water.
Yes.
No, it's formal. Just
వచ్చింది కానీ అది బ్యాటరీ సరిగ్గా లూజ్ కాంటాక్ట్ లేదు.
నేను మిస్ అయిపోయాను లగేజ్ లో. నేను తెస్తాను, మర్చిపోయాను. ల్యాప్టాప్ చార్జర్, ప్రజెంటర్ మర్చిపోయాను. అదే పెంటర్ పట్టుకొచ్చాను. ఆల్రెడీ ఐ గాట్ వన్.
అదే మీకు షాల్ వచ్చింది అంతే.
సో డోంట్ డూ దట్. Let's save some time.
So we are happy to felicitate Professor Rajshekhar Garu on behalf of Department of Mathematics, UASMS and SMS. So that's wonderful lecture.
Maybe somebody should take a picture.
Sure.
Ashar, Srinivas.
Rendu sir. Nanaji rendu.
Thank you very much, sir. Oh, already I got. Okay. Thank you.
Now we are thankful to Professor Rajan Prasad Garu for chairing the Kanaya Jars invited talk session. Sir, please, we want to thank you.
Oh, thank you.
We are also thankful to Professor M.V.S. Murthy Garu for chairing the session of invited talk by the Sir, please. Please, need it. No, please. Please. Here, let us express our gratitude. సార్ అనితా తోమర్ గారు ఆన్లైన్ ఉన్నారా చూడండి. నేను
Next session is invited talk by Professor Anita Tamar, online, and chaired by Professor P. Anuradha Kameswari Madam. Madam, please chair the session.
సార్ మేడం జాయిన్ అయ్యారా? మేడం వాజ్ ఆన్లైన్. చూద్దాం కాసేపు. ఋషికేష్
మాట్లాడు ఇది వీడియో అంటే అదే ఇది వీడియో అంటే వీడియో సరే చేసిన హాయ్ శ్రీనన్న మస్తు ఇది ఇప్పుడు నేను
Now see, ma'am.
నా దగ్గర
Sorry, ma'am. I couldn't understand, ma'am. Please, sir.
Can we start? The first paper presentation by D.K. Jyoti. A comparison of flow of magnetic and non-magnetic nanotract particles in sodium alginate and non-Newtonian nanofluid over a flat plate. You can start here.
Yes, ma'am. The PPT will not showing in the full screen, ma'am. I'm waiting for that.
That's some technical problem, Mama. Please proceed. That will cause unnecessary problem.
You can proceed now. Now it is visible for us.
Okay, ma'am.
Change the slide.
Cursor is not working. One second, ma'am.
One second. You must slideshow. You close that left side one. That
Screen is not working, ma'am.
You close first.
Which
and
one?
Then start the slideshow. You close it start the slide share.
Which close it, ma'am?
Left hand, extreme left, go to extreme left. Go to extreme left, you have a close there, you see?
This one, ma'am.
Down. Downwards. Extreme left, downwards.
Down, ma'am.
That column you have to close, that is unnecessarily open, no? Close it. That. You have a close there written. అది క్లోజ్ చేసి స్లైడ్ షేర్ చేస్తే పెద్దదవుతుంది. మా క్లోజ్ చేయండి, అది లెఫ్ట్ సైడ్ క్లోజ్ అని ఉంది కదా. యు ఆర్ ఫ్రమ్ విచ్ ప్లేస్ అమ్మా? యు ఆర్ ఫ్రమ్ కర్ణాటక?
Yes, ma'am.
You have to start your slide share. It is there on.
It is not working, ma'am.
Slide share.
Next slide is not working, ma'am.
Slide to slide you can click. Either you can click slide to slide. Second slide you are unable to. It is not opening.
Yes, ma'am. Not opening, ma'am.
You have to close the tab, left side tab. Left side one, you have to close that and then start the slide share.
Can I once again?
Yes, do.
Yes, ma'am.
చిన్నది చేసేయండి, చిన్న చేసి షేరింగ్ ఎందుకు
Is it opened, ma'am?
Now yes.
Okay, ma'am.
Full screen, make full screen slide.
Yes, ma'am. Is it okay, ma'am?
If possible, we want big.
Are you seeing, ma'am?
We are able to see, but we want a full screen. Slide share. Bottom. Right side bottom, you will have a glass symbol, it seems.
Glass symbol.
Bottom, you have a glass symbol. Down. Yes. Yes. That on to your left. To your left. Yes. Down.
This one, ma'am.
Left. That symbol you have to click on.
Which symbol, ma'am?
Glass type symbol. On to the left. Yes, below. You take some time.
View. You can also another go to that view, full screen mode. Go to the top menu view.
Top menu view. Go to full view mode there.
Yes, ma'am.
Top view. View.
My left, ma'am.
In your tab, you have view written, no? On the top. Will you forward it to our mail?
Yes, ma'am.
So we will proceed to the next stop. We will, when it is ready, we will contact you again.
Yes, ma'am.
Okay.
Okay, ma'am. Sorry for the disturbance. Thank you.
Okay.
Sorry, ma'am.
So the next presentation is by Suryanarayana P.S. Konnu. చేసుకోను. ఎస్.
On certain investigations on behavior of de-declaration parameter with the bulk versus cosmological models.
కనెక్ట్ అయిపోయింది మాస్టర్. ఇప్పుడు ఏం లేదు ఇక ఇది ప్రజెంట్ నౌ అంటే ప్రజెంట్ అయిపోతుంది. ఇది మీది వీడియో ఇప్పుడు స్టార్ట్ చేయాలన్నా? స్టార్ట్ చేసినట్టుగా చేసి కట్ చేయండి. సూర్యనారాయణ ఆమె ఆల్రెడీ ప్రజెంట్ చేస్తుంది మాస్టర్. ఇప్పుడు ఏముంది ఎంటర్ స్క్రీన్ అని చెప్పాలి. స్క్రీన్ ఓకే షేర్. ఇప్పుడు మీ స్క్రీన్ పోతుంది. పోయిందా? మీ పీడిఎఫ్ ఓపెన్ చేసుకోవాలనుకుంటే ఓపెన్ చేసి బ్యాక్ ఏముంది పోతుంది. షేర్ అయిపోయింది ఆల్రెడీ. షేర్ అయిపోయింది కనిపిస్తుంది అలా. ఇప్పుడు మీరు ఇక్కడ చూసుకుంటే అక్కడ కనిపిస్తుంది. అలా కనిపిస్తుంది ఆల్రెడీ. స్టాప్ షేరింగ్ అంటే ఆగిపోతుంది. స్టాప్ అయిపోయింది అంతే. ఏం లేదు ఏం లేదు మాస్టర్. ఇది ఉందా మీది? ఇదేది సార్? ఇది గూగుల్ మీట్ ఉందా? ఏడ ఉంది సార్? అది ఇప్పుడు ఇది ఎట్లా వచ్చింది? గీడ నొక్కన్నా ఆడ కాదు. ఈ కంట్రోల్ ట్యాబ్ ఇట్లా నొక్కితే రెండు వస్తాయి. రెండే ఉన్నాయి ఇప్పుడు. ఇగో ఇది సెలెక్ట్ చేయండి. షేర్ నౌ. ఏది సార్? గీదా ఈ బటన్ సెలెక్ట్ చేయండి మాస్టర్. షేర్ నౌ అనండి. ఇప్పుడు వాళ్ళు షేర్ చేస్తున్నారు కాబట్టి అడుగుతుంది, లేకుంటే డైరెక్ట్ తీసుకుంటది. షేర్ నౌ అన్న తర్వాత ఎంటర్ స్క్రీన్ అనాలి. ఎంటర్ స్క్రీన్ అంతే. ఎంటర్ స్క్రీన్ షేర్. స్క్రీన్ మొత్తం ఇది షేర్ అవుతుంది. ఇగో మీ స్క్రీన్ మొత్తం షేర్. ఇగో మీది కూడా కనిపిస్తుంది చూడండి. ఇక్కడ కనిపిస్తుందా? ఇది మీ స్క్రీన్. ఇంకెవరు ఈశ్వర్ సత్యనారాయణ ప్రజెంట్ చేస్తున్నారు. ఇప్పుడు ఇది చేస్తే ఇది వాళ్ళకి కనిపిస్తుంది. మీకు కనిపించదు. మీ స్క్రీన్ అంతా కనిపిస్తుంది వాళ్ళకి. మీరు ఏది ఉంటే అది కనిపిస్తుంది. ఓకే అర్థమైందా? అయ్యో రామా. ఇప్పుడు 4 అవుతుంది. మీరు ఇప్పుడు స్టార్ట్ చేయాలి. స్టార్ట్ చేసుకోవాలా?
హలో హలో సూర్యనారాయణ గారు. హలో
హలో, గుడ్ ఆఫ్టర్నూన్ సార్. సార్ myself Pupil Srinivasulu, research scholar from Dr. B.R. Ambedkar Open University, Hyderabad.
Srinivasulu garu, you want to present now? Srinivasulu garu. Kolluru Srinivasulu.
ఆయన కాంటాక్ట్ చేశాను. ఆయన రెడీగా స్క్రీన్ షేర్ చేసి చెప్పండి. మీరు అడగండి, చేస్తారా అని అడగండి. ఎవరో ఒకరు తీసేయండి అమ్మా అక్కడ. ఇది అయిపోయింది చూడండి. మీరు చేస్తారా? మొబైల్ మనకి అది కనిపిస్తుందా? మా ఇదైతే కానీ రారమ్మా ఒక్క నిమిషం ఇక్కడ అయిపోయినా అమ్మా సూర్యనారాయణ గారిని కూడా మనకి
హలో మేడం
సూర్యనారాయణ గారు
సార్ నమస్తే సార్ ఇది రొటేట్ అవ్వట్లేదు మేడం ఇట్ ఇస్ నాట్ రొటేటెడ్ మేడం
నాట్ రొటేటింగ్ మీరు మాకు షేర్ చేసారా
ఎస్ సార్ ఎస్ సార్ ఇట్ ఇస్ షేరింగ్ బట్ ఇస్ నాట్ రొటేట్ సార్
షేర్
ఫోన్ ఆప్షన్ అండి ఫోన్ లో రొటేట్
can madam can I explain like this madam, sir
carry on
carry on thank you ma'am in the study I am KPS Suryanarayana under guidance of Dr. KVS Series sir, Department of Mathematics GSS Geetham Deemuttubi University Visakhapatnam. Abstract. In this study, we have examined bulk viscous cosmological models of Quantum sources in the context of the F40 theory of gravity. To identify the model solutions, a parameterization of the deceleration parameter is taken into consideration. This DP parameterization simplify to the linear varying deceleration parameter LVDP occurs in Dereli 2012 and the bilinear varying deceleration parameter BVDP Misra and Dew 2019 for certain values of model parameters. We discuss the cosmic evaluation using LVDP in model 1 and BVDP in model 2. Both results illustrate a phase transition from the early cosmic deceleration phase to the current acceleration phase. We graphically analysis and compare the models physically and geometrical features. And reduction, dp is dimensional quantity and is defined as q is equal to minus a double dash a by a square, where a is an average scale factor, q greater than 0, indicates decelerated expansion phase of the universe, while q less than 0 shows decelerated cosmic expansion phase. Accorsu and Berylli 2012 have introduced a linear varying deceleration parameter, that is LVDP, q is equal to alpha 1 minus alpha 2 t, where alpha 1 and alpha 2 are non-negative constants. Sir, one more thing, sir. Yes. Sir, one more thing, sir. It is not open, sir. Sir. Further, a cosmological model with bilinear varying deceleration parameter BVDP, that is q is equal to alpha into 1 minus 2 by 1 plus t, alpha greater than 0 in the branch decay theory of gravity, has been examined by Misra and Chand 2016. Using this cosmological model metric, ds square is equal to dt square minus a square dr square minus b square d theta square plus sin square theta d phi square, and t is the tensor p plus rho plus p bar ui uj minus p bar gi is a. The gravitational field using F40 gravity is F40 F1 of r plus F2 of t where F1 are defined as alpha, lambda 1 r and F2 is defined as lambda 2t. This is Einstein equation Rij minus 1 by 2 Rgij is equal to 8 pi plus lambda 2 by lambda 1 Tij plus P bar plus T by 2 into Gij. Solving all these Christoffel symbols and using previous equations, Christoffel first and second Christoffel symbols using, you get these field equations. These 4 equations, we get solving these 4 equations, we get A, B and rho, energy density and P bar as well as Q, deceleration parameters. When LVDP model 1, alpha 1 minus 1, Q constant dp q is equal to alpha 1 minus 1. For LVDP q is equal to alpha 1 minus 1 minus alpha 2 t. And for DVDP q is equal to alpha 1 minus 1 minus alpha 2 t by 1 plus alpha 2 t. Using barotropic equation of state relating the non-viscous fluid pressure P to the energy density of fluid, that is P is equal to gamma P, where gamma is 0 less than or equal to r less than or equal to 1 is a constant. Solutions of the models given here. As discussed, actually the values are not visible here, sir. Sorry to this. As discussed above, we consider LVDP q is equal to alpha 1 minus 1 minus alpha 2 t, alpha 1 alpha 2 greater than 0 in model 1, and BVDP model 2 q is equal to alpha 1 minus 1 minus alpha 2 t by 1 plus alpha 2 into t, where alpha 1 alpha 2 greater than 0, these are all constants in model 2 for finding the solutions of the field equations. Model 1 H is equal to a double dash by 1 by 3 into h a dot by a plus b dot by b plus c dot by c. Solving this, we get 2 by t into 2 alpha 1 minus alpha 2 into t. A average scale factor k into exponential of 2 by alpha 1 into tan h inverse alpha 2 t by alpha 1 minus 1. Similarly, model 1 rho value, the equation we have solving all the solutions. 4 equations solving, we get P bar, rho and H. We get P rho value this one. And model 1 P bar value this one. And model 1 P is pressure. And model 1 chi, this is one parameter, K3 into alpha 2t minus alpha 1 plus K4 into t by 2 alpha 1 minus alpha 2t whole square plus K5 by K1t plus K2 whole square into t into 2 alpha 1 minus alpha 2t. This is one parameter. Similarly, we find V is equal to a power 2n plus 1 minus n into K1t plus K2 whole to the power 2n plus 1 by n. Theta is equal to 3h 6 by t into 2 alpha 1 minus alpha 2t. Sigma square is equal to 2n square minus alpha n plus 2 by 2n plus 1 whole square into 6 by t into 2 alpha 1 minus alpha 2t whole square. A is equal to 6n square minus 12n plus 6 by 2n plus 1 whole square. This is for model 1. Same values in model 2 BVDP. For BVDPs, q is equal to alpha 1 minus alpha 2 t by 1 plus alpha 2 into t. H is equal to alpha 2 by alpha 1 log 1 plus alpha 2 into t. Average scale factor A of t is equal to c into t power 1 by alpha 1 into exponential of k2 into 7. Similarly, rho value. This is rho value 3 into 3n plus 1 into minus alpha 1 by 1 plus alpha 2t into alpha 2 by alpha 1 into log 1 plus alpha 2t whole square into 2n plus 1 into c1 minus c2. C1, c2 are constants here. Plus 9 into alpha 2 by alpha 1 log 1 plus alpha 2t into 2n minus 1 into n minus 1 c1 minus c2 into 3n plus 1. Here c1, c2 are integral constants. Minus 1 by n into k1t plus k2 whole square into 2n plus 1 whole square c1 plus 3 into 2n plus 1 into c2.
Last 1 minute, please complete that, please.
Sir, next P bar.
Please conclude.
Sir?
Please conclude.
Sir, P bar and model to P is equal to gamma P, and this is on constant parameter chi, and also in model to V is equal to a power 2n plus 1, and theta is equal to 3h. Some graphical representation of model 1 and model 2 here. Sorry to say, sir, in mobile is not visible in table. This is conclusion, sir. In this manuscript, the authors have studied two countless as bulk viscous cosmological models in aquatic gravity with variable dp. The presentation of dp has been considered as q is equal to alpha 1 minus 1 minus alpha 2 t by 1 plus alpha 3 into t, alpha comma alpha 2.
Next. Next paper presentation online by Rizwan Sheikh. Are you ready, sir? Are you there? Rizwan Sheikh. Rizwan Sheikh. Are you there, sir? Are you going to present? Rizwan Sheikh. Okay, Rizwan, next paper presentation by Rizwan Sheikh on ranking method and graphical method to find the critical path of a fuzzy project network with the trapezoidal institutionistic fuzzy numbers as activities. Over to Rizwan Sheikh. Please unmute yourself and talk. Rizwan sir, please unmute yourself. Yes. Rizwan sir. Rizwan Sheikh, you're already here?
Okay, madam.
Okay, sir, you can carry on.
Starting. Good afternoon, madam. Good afternoon, all of you.
Good afternoon. You can start, sir.
Good afternoon, madam. So in my paper present, my name is Rizwan Sheikh, research scholar from Geetham School of Science, under the supervisor of Dr. N. Ravishankar Garu. So my paper title is Ranking Method and Graphical Method to Find the Critical Path of a Fuzzy Project Network with the trapezoidal institutional fuzzy numbers as activities. Next, in my abstract, the purpose of the critical path method is to identify critical activities along the critical path, allowing resources to be concentrated on these activities to reduce the project's initiating fuzzy length time. The traditional method of determining the critical path in a project network involves a two-pass computation. Says the earliest and latest times for each activity are calculated. Based on these times, the slack time for each activity is determined and the initiation fuzzy critical path of the network is established. In this paper, we construct a rooted tree for the institutional fuzzy project network. Using institutional fuzzy this tree allows us to find all paths in the network in a manner that designates the longest path as the instituting fuzzy critical path. Utilizing this critical path, we rank all paths in the project network through a ranking approach and evaluate the float time for each activity. Our findings demonstrate that this new graphical approach is a superior alternative for dealing with the project networks when searching for the initiating fuzzy critical path. Next slide, madam. I represent the trapezoidal initiating fuzzy number. In trapezoidal initiating fuzzy number, the representation of the fuzzy number membership function and non-membership functions of the definitions of the trapezoidal initiating fuzzy number. So I conclude I represent the initiating trapezoidal initiating fuzzy number of the graph. Next slide, the ranking of the functions for trapezoidal initiating fuzzy numbers for the both membership function and a non-membership function. So it utilizes the both membership and non-membership functions. For the membership functions, ranking A1 plus 2A2 plus 2A3 plus A4 by 186. For the non-membership function, rank of A2 equal to A2 dash plus A3 dash by 2 plus A4 dash minus A3 dash minus A2 dash plus A1 dash by 6. In next slide, institutional fuzzy critical path characteristics of a project network with a graphical approaches. So figure 2, I represent the initiating trapezoidal fuzzy project network described using n-array T representation. This method is constructing the n-array T representation is explained by considering the initiating fuzzy project network. But in figure 2, the n-array T representation in figure 3 from n-array tree representation, it is clear that the 4 paths, 1, 4, in figure 3, 1, 4, 5, 6 is one path, 1, 3, 5, 6 is one path, 1, 4, 6 is one path, 1, 2, 6 is one path, total 4 paths. So next slide, the proposed method initiating fuzzy project network with membership and non-membership function. These are activity times for both membership and non-membership functions, all of the activities. Next slide. So in this slide, project network with initiating fuzzy numbers are representation in figure 4, and that means membership functions and non-membership functions activity times are represented in this figure. Next, figure 5. Next slide. Figure 5, n-array T representation for the project network. Left side is membership functions, and figure 6, n-array T representation for the project network. non-membership functions. So in the slide, membership function and non-membership functions of the project network is represented. Next, last conclusion, madam. The present paper proposes an narratory representation of identify the initiating fuzzy critical path and project characteristics in a fuzzy project network. Here, a new method is using initiating trapezoidal fuzzy numbers has been introduced for finding the critical path in a fuzzy project network. We have calculated fuzzy total float for each path in the fuzzy project network to determine the critical path using an narrative representation method. In this method, fuzzy total float and path float have been calculated without need to find the fuzzy earliest times and early latest times, providing a means by the initiating fuzzy critical path in an initiating fuzzy project network. So after that, the references are represented, madam. Total references are 10 references. 10 references, madam. Thank you, madam. This is my presentation.
Okay, sir. Thank you. Thank you, sir. Next, Jyoti, madam. Are you there?
Yes, ma'am.
Okay. We are going to present your and Jyoti is her presentation is on a comparison of flow of magnetic, non-magnetic nanoparticles in sodium alginate, non-Newtonian nanofluid Fourier flowchart for a flat plate. Okay, Jyoti madam, you can start.
Yes, ma'am. Good afternoon, everyone. My name is Jyoti DK, research scholar, Geetham School of Science, Bangalore, Karnataka State. And my supervisor is Dr. V. Nagaradhika, Assistant Professor, Geetham School of Science, Bangalore. So, abstraction before slide, ma'am. Previous slide, ma'am. Abstract of this paper here is here we study non-Newtonian sodium alanite with magnetic and non-magnetic nanoparticle, which are Fe2O3 and Al2O3 slip flow over a flat plate. Additionally, we consider the radiation effect and viscous dissipation. The governing partial differential equation is are converted to ordinary differential equation by using similarity transformation. That's obtained ordinary differential equation is solved numerically by Rangekutta method, and obtained result represented by graphs and tables. Clearly, it shows that fluid velocity is significantly increases for high parameters. Also, we can see that rate of heat transfer significantly high in non-magnetic nanoparticle Al2O3 means alumina as compared to magnetic nanoparticle Fe2O3. Here the keywords are sodium alanite, nanofluid, flat plate, magnetic or non-magnetic nanoparticle, viscous dissipation.
Move on the next slide now. Thank you. The introduction of this paper here is fluid mechanics is an important and rich branch of science and engineering, as every living being in the universe cannot exist without fluid. It has wide range of application, including calculating forces and moments on aircraft, determining the mass flow rate of petroleum through pipelines. Generally, the solution of fluid mechanics problem involves calculation of various properties of the fluid, such as velocity, pressure density, and temperature as functions of space and time. Here, the basic definitions in fluid dynamics are Newton's law of viscosity. It states that shear stress on a fluid is directly proportional to rate of shear strain, and Newtonian fluids are the fluid which are linear relationship between stress and the rate of strain. And non-Newtonian fluids are the fluid which shows that non-linear relationship between stress and the rate of strain is called the non-Newtonian fluids. For example, the paste, milk, condensed milk, and printer ink, etc. Move on the next slide. The mathematical formulation of this paper here is already we considered two-dimensional steady flow over a flat plate. Here we taking base fluid as a non-Newtonian sodium alanite with magnetic nanoparticle Fe2O3 and non-magnetic nanoparticle Al2O3. Here, x and y are the Cartesian coordinates, and u and v are the velocity components. And here, Tw is the constant temperature, and T infinity be the temperature outside the thermal boundary layer. Here we can see that the following three field equations we can see here. 2.1 be the continuity equation, 2.2 be the momentum equation, and 2.3 be the energy equation. And 2.4 is the boundary condition present in this problem. And here psi is the slip parameter and u infinity is the free stream velocity. And here QR means the heat flux. That value we are substituting in 2.3. QR is there. Here we have to substitute there and simplify this. We will get 2.5 equation. Move on the next slide now. Thank you. 2.5 it will get 2.5 equation, and 2.6 is the standard effective properties of the nanofluid is given in the 2.6. Next slide, ma'am. Next slide, ma'am. The similarity transformations, the standard similarity transformations are in the 2.7, and here is the eta is the similarity variable, R is the Rex is the local Reynolds number, Vf is the kinematic viscosity of the base fluid, and when you here we have taken U as dou psi by dou y and V is the minus dou psi by dou x. When you substitute in continuity equation, it will get satisfies the continuity equation, and when you substitute 2.7 equation in 2.2, that momentum equation, and 2.5 is the energy equation. When you substitute this and simplify that, it will get 2.8 and 2.9 equation. Here we can see that 2.8 and 2.9, the x and y variables are eliminated, only the variable eta it will get. That means eta is the non-linear ordinary differential equation. That is in 2.9, and the same 2.7 equation substituting in the boundary condition, it will get 2.10 equation. So
In skin friction and Nessel numbers are in 2.11. It will get. Move on the next slide now. When you ordinary differential equation, what we get in the 2.9 equation, you can represent it in graphically. It will get these graphs here. You can see here the in the graph uh, delta is delta is the we can change the parameter point 0.2, point 0.8 and point 1.5. It will f means velocity. It will change increase the velocity here. Similarly, the radiation is changes to 0.2, 1.2, 2.5, then theta it will temperature is also increases. We can see it is in the same way in figure 3 also delta is also changes and temperature here also it is changes here, and see in the figure 5 also. On the next line now. This is here radiation it will increases, Nessel numbers is also increases. Conclusion ma previous next conclusion of this next concluding of this paper here is we have conducted a numerical into the slip flow of a sodium alanite non-Newtonian nanofluid over a flat plate in the presence of magnetic field. Our analysis has also considered the effect of viscous dissipation and thermal radiation. Here we can see that when the temperature is increases, slip is increases, temperature is also increases and velocity is also increases. We can see in the conclusion part, and highlighting the significance of slip effect is augmented fluid motion. And one more thing here is the increase in the radiation parameter corresponding to greater radiative heat flux, leading to generation of more heat within the flux. And the main conclusion of here in this paper here is when heat transfer rate is more prolonged, more in Al to O3 on this than for ferromagnetic Fe3O4 based nanofluid, underscoring the importance of the base material influencing heat transfer characteristics. These are the references of this paper. Thank you.
Thank you, madam. Next presentation, Visual Satyanarayana by Visual Satyanarayana.
Yes, madam. Yes, madam. Madam, visible, madam? Audible, madam?
Yes, it's visible.
Thank you, madam.
Biology actually discuss holographic repeater
Yes, madam.
and
Yes,
the
madam.
cosmological model in branch speaking
Yes,
CDR.
madam. Gravitation.
You can start your
Today my topic is Bank Type 3 Viscous Holographic Wiki Dark Energy Cosmological Model in Bank Wiki Theory of Gravitation under guidance of KVS Sirisha Madam Garu, Department of Mathematics, JAS, Getam, deemed to the University of Visakhapatnam. So first one is introduction. A recent experiment in cosmology substantiates the idea that the universe's expansion is accelerating. The interaction between two galaxies caused by an unknown dark element that produces considerable negative pressure is generally dark energy. It is compatible with all cosmological substances inside the simplest model, that is within a cosmological dark model. Researchers have hypothesized that radiation and ordinary matter account for 5% of the universe's present energy. the remaining 95% dominated by this dark component to explain the universe's ultimate rapid growth. This dark sector of the universe is composed of two significant factors, dark energy and dark matter. The significance of dark matter is mostly in structural conformation, similar to allowing chronic structures to decouple from photons and become non-linear. Dark energy is considered to regard for 73% of the energy in 73% of the energy in our universe, with dark matter accounting for 23% and baryonic matter accounting for the remaining 6%. Two main approaches proposed to explain this late time acceleration. The first is to investigate better dark energy possibilities, and the second is to investigate modified Einstein theory of gravity. To characterize the behavior of dark energy events, the equation of state parameter W equal to T by rho, where rho represents pressure and P represents pressure and rho denotes energy density, is generally employed. The equation of state parameter W with the range lies between -1 and -1/3 describes the substance dark energy model, whereas W equal to -1 explains the vacuum dark energy, also known as the cosmological constant. And W is less than -1 defines the phantom dark energy model. This phantom dark energy model will nearly clearly affect an incalculable space-time singularity. These are introduction. Main one is objectives. Homogeneous and isotropic bank type 3 cosmological model with pressureless matter and holographic decay dark energy with bulk viscosity in the Browne decay theory of gravity is employed here. To derive the Browne decay theory field equations in the presence of pressureless matter and holographic decay dark energy with bulk viscosity within the bank type 3 cosmological model. And another one is to solve the field equations, and another one is to develop and explain numerous essential physical properties of the model. First one is metric and field equations. First one, consider bank type 3 metric form. This is the bank 3 metric form. A, B, C are functions of T. Next one is bulk viscosity denoted by TSA. Is the holographic Ricky dark energy, energy momentum tensor. Next one is holographic Ricky dark energy TIJH, and another one is TIJ. Rho denotes the matter energy density. Rho indicates holographic Ricky dark energy density. pH bar means the viscous holographic dark energy pressure. And solve the above equations, we will get tensor field equations. Next one is the field equations of Browne decay theory. We get the metric with the backing of equations are these are equations, and another one is HRDE holographic Ricky dark energy cosmological models. From the above equations, we get D equals C1A. For suppose C1A equal to 1, we get B equal to A. Next, we use the following responsible physical conditions to obtain deterministic results. One is proposed expansion scalar leading to the metric potential relation. C equal to B over M and is the arbitrary constant. Next one, we assume that the parameterized kind of bulk viscosity is epsilon. From the above equation, we get the equation. Using above equations, we get A equal to B equal to the value. And another one is from the equations, we get phi equal to some value, and K is the 1 by some, and K to K3 are integrating constant. The Hubble parameter H is the Hubble parameter. Finally, with the assistance of metric potential or frequency witness, ds square equal to this square value. And another one is graph. Graph denotes plot of energy density versus time. For kT equal to 1 and kT equal to 0.85, n value and epsilon value, u value, j value. As they are conserved independently, they are result of the conservation equations. We get the energy density of matter is rho m, K1 is constant, and coefficient of L cos T is epsilon is given by epsilon equal to. And another one is graph denotes plots of viscous preservation versus time.
Vishal sir, please come to the conclusion.
Conclusion, this study investigates the spatially homogeneous and isotropic bank type 3 cosmological model with bulk viscosity in the presence of pressure, less matter, and holographic Ricci dark energy in the bank theory of gravity. It is pivotal to note that the physical volume increases with time. The above figure 4 illustrates the volume considering constant time. Next, we can see that as the time t rises, the spatial volume being increased and ultimately becomes infinitely large. As displayed in the graph, it demonstrates that the cosmos expands as the time goes. These are conclusions and references. Thank you.
Okay, sir, thank you. Next presentation by Venugopal Reddy.
Yes, ma'am.
Okay, sir. On enhancing heat transfer efficiency, entropy, optimization of hybrid nanotubes, dedicated nanoparticles slowly rotating this. You can start, sir.
Ma'am, one second, ma'am. I will share the file, ma'am.
Okay, sir. Okay, sir.
Yeah, ma'am. Ma'am, is it visible, ma'am?
Yes, sir. Yes, sir. But come to the screen share. Full screen, sir. Slideshow otherwise. Top slideshow is there, no? Middle. Yes, in the middle.
Yeah, ma'am. Yeah. Good afternoon, ma'am. My name is Venugopal Reddy, research scholar from JNTU Anantapur under the guidance of Raghukumar sir, ma'am. I am pleasure to give a presentation on enhancing heat transformation efficiency, entropy, optimizing of nanofluid with blood modulated nanoparticles over a rotating disc, ma'am. Here,
So make it a slideshow, sir, please.
yeah, ma'am. In this research, I'm studying entropy and different nanofluids, ma'am, like gold, silver particles, which are together with boiled blood and the flow, like rotating disc, like that parts, ma'am. I am doing the research work on EMHD, ma'am. That means electromagnetic hydrodynamics and Cashnov flows and Williamson flows, heat generation, how the thermal radiation is changes from one particle to other particle, and also study on boundary conditions. Next, forest media also I am studying on this, ma'am. This is the introduction. Next, objective of this study is to analyze the heat transfer characteristics of Casson Williamson hybrid nanoflow system in EMHD development. In this model, I am doing some similar transfer equations, governing equations, and I converted into PD to OD. Then I use RK fourth order numerical method to solve the equations, ma'am. And also I analyze ANNM, it means artificial nano Nuclear algorithm to represent graphs, ma'am. It is the it is having potential application in implementation of that means in biochemical field, ma'am. The research,
Sir, 1 minute. Sir, come to the slideshow.
the research methods is I am review many literature reviews for this, ma'am, and also I follow the method of RK fourth order solving method for ODPD equation solving, ma'am. Then I graphically represented with MATLAB, ANM lab algorithm to graphical representation and compare how the particles are changing from one to other when flow is there, ma'am. This is the mathematical description. First equation is momentum equation. Next to
Sir, am I audible?
yeah, ma'am, yeah, ma'am.
Sir, you first come to the full screen, then we can explain.
But then, ma'am,
Slideshow at the top, it is there, no? After the animation. Slide, at least move the slides.
Yes, ma'am.
Okay.
The slide is it visible, ma'am?
Visible slide visible only, but it's a half slide. Full screen you
Ma'am,
can.
full screen I put full screen mode only, ma'am.
The top animation after the animation slideshow is there, no? Otherwise, in the bottom it is a glass. Yes.
Yeah, ma'am. This only full screen mode only I put, ma'am.
Okay. Okay,
yeah.
Sir. Carry on.
Is it
Okay,
visible,
sir.
ma'am?
Visible only. Visible only.
Yeah, ma'am. These are the mathematical equations I formed for this project, ma'am. First one is continuity equation. Dou W by dou Z plus 1 by R dou R UR is equal to 0. Second one is the momentum equation. Third one is the energy equation. It is also the temperature equation, ma'am. Here E0 is for Cation flow. B0 is for Williamson flow, ma'am. These are the U, V, BTR are the temperature and velocity gradients, ma'am. This is the mathematical model that I taken, ma'am. By solving the equations in RK shooting model, I adapted these values, ma'am. I represented this in a graph mode. In this red line shows the gold particles moving system, ma'am, and blue line shows that AG, that means silver particles moving. Thus, ma'am, these are the findings that I found in this research. Is the entropy of different particles are different, and heat generation is less when we together the many. That means entropy optimized techniques applied to hybrid nanofluid systems are anticipated to lead the reducing the entropy generation during heat transfer process. The study identified optimal concentration of nanoparticle flows and rational speeds of maximum heat. That means heat is changed from one place to other place, ma'am. These are the findings, ma'am. The conclusion is entropy generated EMHD, AU are silver particle, blood flow with Williamson and Casino flow, as well as the heat produced and abstract of a hybridized nano approach over a rotating disk have all been investigated in this research, ma'am. This approach may be work well within nano drug delivery systems, since this work often a deeper compression of the hemodynamics transformation of gold and silver bled via an artery with an uneven strategies, ma'am. The results, that means here I found equations for continuity, momentum and energy are used to illustrate the blood flow problems governing equations, ma'am. The results PDs are solved by HPM technology and RK fourth order technology and convert them into ODs,